Hello and welcome to aorbtech. Today we're going to start another series about pandas, and in this series we'll cover from basic to advanced tutorial. So today's session is just introduction, where we will more focus on theoretical part, and in the further tutorial we'll start a practical as well. So the agenda of today meeting: first we'll see the introduction to pandas, then founder and why we use pandas. After that we'll see how we can install pandas and use, and then what you need to learn before going to start pandas, and in the last we'll see outline that we will cover. Introduction to pandas. Pandas is a Python library used for data analysis and manipulation. For example, if you want to do some statistical analysis and you wanted to understand the data set, and while you do multiple operation, for example grouping, filtering, conditional statement, or modify or delete some columns, that's what we use pandas. Also when we're working with the data set, it make us much more easier if we use pandas, especially when we're working with the tabular data, where we can handle multiple files. For example, we can read or write files such as tsv, json, csv, excel, sql. Founder of pandas. The pandas library was funded by Wes McKinney in 2008 while he was working at AQR Capital Management. So he basically created Pandas library because he wanted the tools which help him to solve the financial data in terms of flexible, efficiently, and fastly as well. And this pandas name also came from a panel data as well. Why use pandas? Much faster and more powerful than Excel. For example, if you're working on 1 million of rows and you're working on Excel, just imagine that. That's why we use pandas. It makes us work much more faster and it's more powerful actually. And the second, easy to use, especially if you are working as a data scientist, analyst, and ML engineer, because you are working, for example, on analysis, try to understand the data set, or you wanted to work as an ML engineer where you are more focused on quality of data. So that's what we use pandas for. And the last point, works very well with other libraries, for example numpys, as we already seen in previous series as well, matplotlib, which we'll cover in the next series, scikit-learn, tensorflow, and keras. Then pandas is really compatible to working with those libraries as well. Prerequisite to learn pandas. So first you need to understanding of Python programming language, because without that you won't be able to understand pandas as well. Then numpy as well, because numpy is used for multi-dimensional array, and based on those knowledge we can do data manipulation and analysis as well, that we will cover in this series. But we already make a complete course on those topic, Python and numpy. If you didn't check this one, go and check, and then after that you will be easily understand the pandas as well. Outline of this course, what we're gonna cover in this course: first we will work on series, data frame, then we will see how we can read and write CSV file. After that we'll work on data manipulation, such as we can work on missing values. Then we'll see how we can fill those missing values while applying different operations and method as well. Then we can see some replace, interpolate function as well, which also used to handle the missing values. After that we will see how we can select column by indexed or by their names, and then we will see some various functions such as group by merging and concatenate as well. After that, we will see a different method to join different data frames such as join, append, and then we'll see pivot table, and in the last we will cover melt function as well. For source code, you can visit the following link where you can download the code where you can use in your practical.
Hello everybody and welcome to the second installment in the aorbtech Pandas series. Today we're going to be looking at the Panda series. In this episode we're going to be looking at creating, updating, and accessing a series, and then we're going to be looking at some series operations. Let's start as always by importing pandas. Let's go down here, create a code block, and import pandas. And it's taking a little while, but there we go. Now we can move on to the next part. So let's create a series. First of all, let's create a code block, and we're going to create a variable. Let's call it series 1. I'm going to say it's equal to, we're going to use the pandas. Then we're going to put in series, and we're going to put in a list. And so we can just put in whatever numbers we want. Why not? And we're going to print our series 1, just to see what it looks like. And there we go, we have our series. To create an empty series, all we need to do, starting with a code block, let's create a variable called empty series. Let's set it to pandas.series. Then we're going to put in an empty list. Finally, we're going to print our series, our empty series, just to see what it looks like. As you can see, we have an empty series. If we want to create a series in which all elements are identical, we can use something called a scalar series. Let's start off by making a code block. Let's create a variable called scalar series. We're going to use pandas series, and we're going to put in a single integer, let's say 5, and let's print our scalar series to see what it looks like. Now this has a single element. If we want to create something a little more exciting, like a scalar series with multiple elements, we'll need to use a different method. We're going to use something called index, which we'll take a closer look at later in this episode. Let's create something called scalar series 2. That's our new variable. Again, we're going to use pandas series. Within, we're going to put in our value 5. And then we're going to use a comma to put another argument inside. We're going to use braces, and we're going to put in our index, which we're going to set over here. This should have 5 elements, and once I create this and print it, all of the elements within should be this value here, 5. And as you can see, that's exactly what we get. Let's take a look at updating a series, starting with the index argument, which we used in the prior example. Start a new code block. Let's create a series 2 variable. We use pandas series. We get the gist by now. We're going to put in a list here. Let's say 1, 2, 3. And then we're going to say that the index is, let's say something like A, B, and C. Now if we print series 2, we should get a series where these are the elements and these are the corresponding indexes. As you can see, that's exactly what we get. Let's look at data type. So what this allows us to do is change the data type of a series. So let's create another series. Let's call it series 3. Pandas series. Then we'll put in some values. Let's say 2, 4, 6, 8, and we'll change it so the data type is, for example, a float. So these should become numbers with decimals at the end. Then we're going to print series 3 and see what it looks like. As you can see, now all of these numbers have decimal points. Now this will try to typecast whenever possible, but when it's not possible, it'll give you an error. So let's take an example of that. Let's create a variable called error series 1. We're going to use pandas. We're going to use a capital S with that series. Then we're going to put in A, B, and C as our elements. And we're going to try to change the data type into an int. Make sure we spell pandas correctly. Now I would try printing this, but it's going to give us an error anyway, so let's just run this piece of code. And as you can see, we get an error here because we can't convert these characters or these strings into integers. Let's take a look at column name. So let's create a series. I think we're up to series 4 now. Pandas series. Then we're going to put in some random numbers, 4, 6, 9, 3. Right, and we're going to change the column name by using name equals, and then we're going to put in something like numbers. Then we're going to print our series 4. See what it looks like. As you can see, as with above, we got data type. This time we get the data type and an additional parameter here, which is the name, which is the one that we gave it here, numbers. Now we have all these series that we've created, but how do we access the elements inside? Well, that's what we're going to be taking a look at now, starting with index. First, let's print our original series to see what it looks like. There we go. Now that we have that, we have each element with their corresponding index. So we're going to use the first method of accessing the elements inside our series, which is going to be using the index. And to do this, we are just going to use brackets. So let's say we have series 1. We're going to put in our brackets, and let's say we want to access this number 16. We can see the element, the index is 3. So we put in a 3 in our code. And if we run that, we should get 16, as you can see. Of course, we can also print this. So we get something nice and clean. But yeah, there you go. It's pretty easy. Let's do this maybe one more time. Let's print our second series. And now, as you can see, our indexes here are characters. So what we can do is print series 2, again using the brackets, and we'll put in our character. Let's say we want to carry access 2, so we'll put in B because that's the index for that particular element, and we get 2. So you can still use characters, you can use whatever it is that you decide to be the index, and you'll be able to access the elements inside of your series. Next, we're going to be taking a look at slicing. Now, we've used slicing plenty of times before, so I'm not going to explain it here. But if you would like to learn how it works, we also have a Python series and we have a NumPy series where we go through slicing extensively. So we're just going to do a simple example here. Let's print our series 3 really quick to see what it looks like. And let's say we want to access the first and second elements. So we're going to use our series 3 one more time, use the brackets one more time, and we have this layout that we usually have. So we have the start, the end, and the step by. Let's say we just want to access those 2 elements, right? So we have 1 and 3, non-inclusive. There we go, we have only those 2 elements. Now let's say we want to access every even element, even index element. So let's print series 3. I'm going to use our brackets, put double colon, and then we'll put 2, so step size 2. And there we go. So yeah, pretty simple implementation of our slicing, which we've done plenty of times before. Again, if you're confused, check out our previous series. We look at this extensively. Now let's look at some series operations, starting with max. So let's create a new code block. Let's print our series 4, so we know what it looks like. And let's say we want the largest number in this series. So we'll use max, the max function, and we'll put in series 4. And let's print this as well so we get something nice and neat. And it's that simple. And the same goes for min. We can just create a new code block here. Let's print min function, apply it to series 4, and we get the number 3. Now let's verify this. If we go here, we have all these numbers here, these elements on the right side. And as you can see, 3 is indeed the smallest number and 9 is indeed the largest number. So these check out. Let's take a look at compare, which is a little bit more complicated than the previous two. Let's first print out our series 1 because there's plenty of elements which we will need for this example. As you can see, we have all these 6 elements here. Now, what this allows us to do is it allows us to pick out a select group of elements that fit a certain criteria or a conditional statement in our series. So how do we do this? Well, first of all, let's print it out so we have a nice result, something clean. And then we're going to use our series 1. We're going to use the brackets. That's the syntax we use. And this might seem a little unintuitive, but we're going to put in series 1, and then we're going to put in the conditional. So let's say we want all elements greater than 15, right? So series greater than 15. We get 16, 23, and 32, which is exactly what we were looking for. Now, let's do another one just to practice. Once again, we'll print it. We'll put in our series 1, and we want the condition that the elements in series 1 are equal to 4, for example. If we had more elements in this series, it would give us all of them, but for now, we just have this element here at position 1. Finally, let's take a look at add. Now what this does is it goes through each index of 2 or more series, and it adds the elements at those indices. So to start off, let's print our series, let's say 3, and then we're also going to print our series 4 so we can take a look at them. I picked these because they have the same number of elements, although you can apply this to 2 different series who have a different number of elements. Just note that the latter of those elements will not be added together. So as you can see, we have these numbers here. Now, let's say series 5 is equal to series 3 plus series 4. And then we're going to print series 5. See what it looks like. So we get the element 6, 10, 15, and 11. As you can see, we have 2 in the index 0. We have 4 in the index 0 in this series. So if we add those together, we get 6, and that's the first element of this one. Let's go to index 1 of the series 3. As you can see, we have the number 4. And then let's go to the index 1 of series 4. We have a number 6, so 4 plus 6 gives us 10. And as you can see, at index 1 of series 5, that's exactly what we get. And you just repeat this process for every single index. Now, let's say we have a series which has more than 5 elements. For example, series 1. Now let's print the addition of series 1 to series 4. As you can see, it does add the first 4 elements because series 4 goes up to 4, but the last 2 elements, so in series 1 we have 6 elements, so from 0 to 5 that's 6. The last 2 elements do not have a value because you can't add nothing to a number in this case. So you just get NaN, which means not a number.
Hello and welcome to aorbtech. Today we're going to continue series of pandas, and in this episode we're going to discuss data frame. So the agenda of today's meeting, first we will discuss how we can create a data frame, then we'll see some various operation while doing update in data frame, such as how we can change the index name or column name, and after that we will see a different way to create a data frame such as like dictionary. So let's start with that. So before going to start with the practical, of data frame. So let's see what is the definition of data frame. So if I explain data frame in a simple way, a data frame is just like a table. So when you see a Excel file with the different values, different columns, either you can see a different CSV file or SQL database, or for example Google Sheet. These all are basically based on a table value. So rows are basically record and column are represent as a attribute. For example, if we have a data house price, and house price we have a column such as a house location, the price of the house, how many bed in this house. So if these are basically attribute. So let's start. So with the practical, before going to start, as we know that we need to import our library. As I already import pandas as pd. Now we can move our practical part, how we can create a data frame. So let's say that I take a variable a and I just simply say that 1 2 3, and after that I am going to create a data frame. So let's say that I just define my data frame name, and simply what I will do here, I will just call my library dot, and because I'm working on data frame, so I will write data frame. After that I will just simply call my variable where I already stored my value a123, and if I run my df, as you can see that we can create a data frame. As I said that 1 2 3, so simply we create one column with the 3 records. So let's take another example. So let's say that I am going to create df1. Simply just write pd dot data frame, and after that we just simply call your value. Let's say that I'm going to take this time 4 value, and if I run my data frame, perfect. As you can see the results where we create 4 records in the data frame. Either you can create a variable, store the value, and then call in the data frame, or simply you can write data frames records directly there. So that's how we can create a data frame. I hope it's clear for you. Let's move a bit advanced part of data frames topic. Let's say that I wanted to create to call data frame, and what I will do here, so simply to call a data frame I would say that df3, simply I would pandas pd, I mean our library, call the name of it, and then simply we create 1 2, and then I say that 3 and 4, and run. And if I run my, as you can see that what we did here, we just create a extra bracket. Now if I run it, and as you can see the results, so here we create two columns data frames. So one of them is 1 2 3 4. So if I take create another data frame name of, let's say that 4, and I would say that I just first column I wanted to, let's say that string value, let's say that, and I simply call my string value, and the second record as well I will take a string value. And if I run, sorry, I need to change the data frame, and if I run, as you can see that, so we create another data frame. So our first column is basically a string value, and the second column is basically a numerical value. So that's how we can create a data frame with different data type. Now we'll see how we can create a 3-column data frame. So let's go with the example. I'll say that I'm going to create a 3-column data frame. And how I can create a 3-column data frame: simply here I take 2 records with 2 columns. Simply you just add extra value in both array. So if I show this example, for example, I create one first column with based on string, the second column is basically based on numerical, and the third column is basically represent our float value. And if I run my df5, as you can see that we create a 3-column. By default name is 0, 1, 2. Don't worry, we will work on how we can change the name later in the data frame, but just focus how we can create a data frame with a different data type and with a different column. So in a first column we create a data frame with string value, the second one is basically numerical, and the third one is basically a float, as you can see. So that's how we can create a data frame, very easy. Now we will move our next topic, how we can update our data frame. For example, how we can change the data type column name, or how we can change our index name as well. So let's work on that one. Now we'll see how we can create data frame with a column name. So let me copy my first example, this one, and let's change his name. So I just copy, and we'll see how we can change the name. So this is my data frame that I create initially. Let me okay, so here I just create our data frame with one column, and let's change the name. So to change the name, you just add extra parameter with the name of columns, let's say that, and then for example I have only one column, so I simply create one values here. Either if you have a multiple column, then you give a multiple name here. Don't worry, we'll look into that as well. So if I run, as you can see that my column name is number, and I create a values or record, if I say in other words 1, 2, 3, 4. So this is one of the example. If I say that this is my 2-column data frame, how we can rename it. So if I go with that and simply just call columns, let's say that column 1 and column 2, and if I run my results, as you can see that we change the name column 1, column 2 with the value. And if I take this example, let's say that, and I want to name it, the first column is basically my string, second column is my, let's say that, integer and float. So So if I take this example and if I run, as you can see that we simply create a data frame, 3 columns with the name as letter, integers and float, and we have a respective value. In letter we have a string value, in integers we have numerical value, and in the float we have float value 3.5 and 5.6. There's another way to change your column name. Let me show you quickly. So let's say that I create the variable name is a and a store value 123, and I'm going to create a data frame underscore. Simply I just create data frame and I call it, and then as you know that I wanted to change the name, so I would say that column and simply run integers, and if I run my column, as you can see numbers 1 2 3 3. So what I did here, so basically I create a variable and I take array and store a 3 value. After that I create a data frame by calling data frame name, library is pd, and then I simply call my df underscore dot columns, and then I give the name of those data frame, and then simply I run df underscore. As you can see the results. I hope it's clear for you. Now we'll see how we can change the index name. Let's say that I create a variable b, and then simply I take value 1 2 3, and then I take a data frame name df dot pd dot data frame, and simply I call my variable name. After that I wanted to change the column name, and I say that my columns is equal to name, let's say that number, and then I wanted to change index, so simply you just call the index, and then I say that my index is Roman number 1 2, and my last one is basically a 3. So and all set. Oh, let me change into my Python, and if I run my data frame, and I would say that results, and as you can see that we change our index as well. So first we create a data frame with 1 column and 3 records, and after that we change the name. Simply just call columns, and I change the name number, and after that the third parameter that I pass is basically an index. I just call our Roman numbers here 1 2 3, and I just changed, as you can see. So here we basically apply a 3-way: one data frame, the second one is basically a column, and the third one is index. Now we'll see how we can change the index name in 2 or 3 columns. So let me take this example. For example, and I wanted to rename it, as we already seen our 2 records. So basically, as you can see that we have data. First we have letter, integers and float, and then you have respective 2 records. I wanted to change 0 and 1 with the Romans, so I can change it. So there's another way. same as column that we change it. I would say that dot index, and I say that my index is equal to row 1 or row 2. Instead of, I would say that 1 2, and if I run my this one, as you can see that I rename it. There is another way you can also change the index name as well. How I can do that? I say that simply index name and row ID, and if I run it again, as you can see that we have changed the index name as well, and those are our basically our column with respective values. So I hope it's clear for you. In this topic we see how we can change the index name. Previously we see how we can change the column name. Now we will see how we can create a data frame with a different way. So there is a different way that we can create a data frame. So let me change into Python, and let me write a command first, and I say that create a data frame with dictionary. How I can create a data frame. So I would say that data frame df, and I would say pd dot data frame, and I would change another value in the city, and if I run my index, as you can see, so simply you just create a data frame with the dictionary. You simply first let's say that I wanted to take a 3 columns. So first one is basically key, and those are basically to represent my values. The second column, and then my simply represent the values, and the third one is basically represent values. So that's how we can create a dictionary with data frame. It's much more easier comparative to if I say here you basically you change the column passing another parameter, then you basically calling the record that we want to take, and then you also do row ID, but row ID isn't that important here. So anyway, it's a more convenient. You just simply call the name of the column as a key and then pass the value as a record, and as many as you wanted to create a data frame, you basically take many key and values in a different columns. So if I take one more example, if I say that pd dot data frame pdd sorry I simply just said that pd dot data frame, and I say that my 2 columns, the first one is a as a key and the value is 1 2 3, and the second one is a b with the value is 4 5 6, and if I just simply run, as you can see the results. So basically simply you create 2 columns. First column is a key, pass the value with respective to column 1 2 3. Second value in a dictionary we pass a second key, and then with respect to values 4 5 6. So yeah, that's how we can create a data frame with the dictionary. Now we'll see a second method. Create a data frame I would say that with list of dictionaries. How I can create that? So simply I would say that data frame, and I would pd dot data frame, and if I show the results I can explain the results. So basically you simply take a list here, and inside list you basically pass a dictionary. So for example I create two columns here. So I this is my first column A, and B is my second column. So I constant the name in a second dictionary as well. So basically I create a key with respect to value, and then I pass another key and value, but this is my second column. So as you can see the results A, B, then we create 1 and 3 value in our A column, and then 2 and 4 in another column. This method is actually much more complicated if I comparison with my previous method with dictionary, and mostly people follow this method. Simply just create a name, and then you basically change the column name as well, and after that you simply create index name as well if you want to do. But this is one is also much more convenient, but if you see this method is like with list of dictionaries like much more complicated. You basically pass inside list, and then you basically create another dictionaries and with respective to columns with the keys and values as a record. So let's let me see another example. Let's say that I can create another value is pd dot data frame, and I would say that so I would take this time 3 columns, and I say that my A value is my 1, and then I would say that my B, and then I take a value 5, and after that I would say that C, and I would take a 9 value. So if I run my results df1, what I did here, I create a 3 column with 1 row results. So as you can see that we create a 3 column A, B, C with values 1, 2, 3. If you want to take another one, you simply copy. I would say that passing this value, and I can passing another value, and I just simply create. So you can change the name, but those values are same. As you can see that we have constant value in each columns. But anyway, this is a way you can create with the list of dictionary. I just simply create 3 columns with 3 values in it. So that was our second method. Now we'll move our last method, which is basically a dictionary of cities. So let's say that create a data frame with dictionary of cities. So how I can create those data? So let's say that I create a very simple example. If I take here and if I run, and I will explain this one as well. So what I did here, I basically create another way of our data frame, and this way basically what I did here, I create a data frame with the dictionary of lists. So basically I pass my dictionaries, as you can see, and then I take as a key value basically, or let's say that my column name A, and then instead of passing my values I basically create a series. So that's why how we can call dictionaries of series, and then same second way as well. So previously, if you see, if I show you this example maybe, so what I did here, I basically create a dictionary and then I passing my values, list of dictionaries. So here if you see this example, so simply you can see that I just passing inside values my series. So as you can see the results 1 2 3 and 4 5 6. So that's how we can create a data frame with dictionary of series. Let's see another example. Let me take a one column only. So let's say that I would say that pd.dataframe. Okay, so basically I would passing my values here. After that I passing my bracket, and then I small bracket, and if I run my results, as you can see that we create with dictionary with the series, passing dictionaries key as a column A name, and then we have a series 1 2 3. So that's how we create our data frame with dictionary with a series. So I hope it's clear for you how we can create a data frame with a different array. In the first one we simply see create a different data frame. The dictionary is simply you basically call inside data frame you simply dictionary with respective to values, basically you represent as key values, and then you have another way with a list of dictionaries where you basically pass your list, and then inside you basically pass those dictionaries. As you can see that we create a two columns with two values. Here we create a three column with the three value. In the last one we see how we can create a data frame with a dictionary of cities. So we simply create a dictionaries, and instead of passing the value we just write your series. As you can see the results. That was the end of this episode. In this episode we briefly discuss how we create our data frame. First we simply take a few example, and then we work on how we can update our data frame, for example changing the name in the column or index name, and the last we'll see how we can create a data frame with a different way. So I hope it's clear for you.
And welcome to the fourth episode in the aorbtech Pandas series. Today we're going to be taking a look at CSV files. In this episode we're going to be looking at reading a CSV file, editing a CSV file, learning about their properties, and then we're going to be taking a look at a bunch of parameters and functions which you can see I've listed here. So let's get into it. And let's start as always by importing pandas. So let's create a code block here. Import pandas, and let's run it. And there we go. Now we've got pandas. Let's start off with reading a CSV file. This is pretty simple. We're going to assign a variable. We'll call it students. We're going to say it's equal to pandas.readCSV. And inside the brackets here, we're going to put a set of quotation marks. And you can put in the entire directory of the file that you want to open. It has to be a CSV file. Or we can, if we're in the current directory, we can put /, which means the current directory, datasets, and this is the folder in which we have our datasets in the GitHub repository, which is accessible to you from our website if you prefer. And we're going to use /students.csv. Then what this is going to do is it's going to return our dataset. And what we're going to do is we're going to print it to see what we get. So we have 12 elements here, and we have 4 columns, and each row has an index, which is not in the CSV file. This is a property that Pandas assigns to each of these rows. So just keep that in mind. Now that we have this data set loaded in, or the CSV file loaded in, what we can do is look at its properties. So let's go through each of these one by one. First, let's check what the type is. And as you can see, it's actually being stored as a data frame. And we can actually convert from a data frame to a CSV file using Pandas as well. But let's first look at these other properties here. We'll use students dot columns, and let's see what we get. So we get here a list with all of our different columns: first name, surname, sex, date of birth, and that's all. And as you can see, that's exactly the same as we have in here. Now let's look at info. And that just gives us a little information of how the variable is being stored in the computer. It's useful if you're trying to debug some stuff, if you want to know a little bit more information about how it's being stored. Then we can check its shape. As you can see, 12 by 4. 12 is the number of rows we have, although indexing starts at 0, so it says 11. 4 being the number of columns that we have, as stated earlier. All the columns we can see here as well. Finally, we're going to look at the size. We get 48. So these can be used to tell you a little bit about your data set, about your CSV file, the elements contained within, the rows, the columns, and even how it's being stored in your computer. Now we're going to take a look at editing a CSV file, starting with the parameters. Starting with nRows. What nRows does is it allows us to define how many rows from the CSV file we want to use. So how many of them we're going to pull in. Let's create a code block real quick. And let's create a new variable. We'll call it books. It's going to be equal to pandas.readCSV. Then we're going to put in file location, /, so current directory. Then we want data sets, / and we want good reads.csv. And once again, all of these data sets are available on the GitHub. So there are a couple of them we're going to be using in this episode, and then you can check them out and play around with them on your own. They are toy data sets, so they only have around 10 to 12 rows inside each, so not much data to play around with, but it is a good introductory data set or set of data sets. So let's take a look at this CSV file, see what's inside. Let's run this code, or at least let's print it first. Let's print books and enter. So you'll notice there is one column here that didn't have enough space to render, so it renders here. This isn't a separate part of the data. There's no extra data being rendered here. For your convenience, the indices are still printed on the left, so you can compare them with those found here. So just know that if it looks a little strange, if it looks odd like this, and if there's a slash here, that usually just means that the data that couldn't fit inside has just been put down here. So don't panic if you don't see one of your columns showing up, because especially if you have a lot of data, it won't show up. It'll show up a bit below. So as you can see here, we have a number of books with names, authors, and average ratings, and the number of ratings. And this is from the Goodreads website. we're going to create another code block here. And what we're going to do is we're going to read it again. So, and let's say books5, books_5 is a new variable we're going to create, because we're only going to take the top 5 rows. So that's indices 0 to 4. Again, we start indexing from 0. And we're going to use pandas dot read CSV once again. We're going to put in the name, so we can just take it here, or the directory. And here's where we're going to make the change. We're going to insert a comma, and we're going to add an argument here. So the argument that we're going to add, n rows equal to 5. Then we can print books_5. That's our variable that we created. And what we should see is that we have the same data set, the same ranks, same numbers, except that we're only going to get the first 5 entries, the first 5 rows. So let's print it. We'll run the code and see what we get. Exactly what we bargained for. A slight difference being that since there is less data, we actually did have enough space to fit in the no ratings area. And that's not because we have less data, that's because the entries which took up more space, as you can see, so at position 6 and 7, immediately after 5, were not included. So we have a little bit more space, as you can see, a little bit less than for this one, to fit in all of these entries, and that's why that's happened. Taking a look at use calls or use columns, essentially what it does is quite similar to n rows, except that instead of selecting the rows, we're going to be specifying which columns we want to use. So let's once again use our books CSV, our books data set. So, and just to simplify it, we'll use n rows as well. So we'll say we'll take the top 3 so we don't take up too much space. Then we're going to use pandas dot read CSV. Then we're going to put in the directory, and we're going to say n rows equals 3. That's just the number of rows we're going to be using, so we're going to truncate it to these 3 just so it doesn't take too much space. And now let's specify the columns we want to use. So this is the important part here. Use calls. We're going to say, first of all, we need to put in a pair of brackets there. And let's say we don't want to know the rank. We don't want to know the author or the number of ratings. All we want to know is the name and the average rating. So that's, we can put in name here and AVG underscore rating, so average rating. Then we're going to print books 3. There we go. And as you can see, we don't have the rank, we don't have the author or the number of ratings, we just have the name and the average rating. We can copy this code and we can change this here to use the indices instead. So the rank would be 0, name would be 1, so we can input 1 there. Author would be 2, and average rating would be 3. And we should get the same thing, so let's print it. There we go, the name and the average rating. So there are 2 different ways of using this method, and that's exactly how. So let's move on to the next. Skip rows allows us to indicate which rows we don't want to include in our data set. Let's start by importing a data set. So let's call it films. It's equal to pandas dot read CSV. We'll put in the directory, so current directory. Then we want data sets, and we want to put in imdb.csv, once again available in the description, so by our GitHub or website. Then print it. Once again, do not be alarmed if some of your columns get moved to this lower section here. But how do we fix that? How do we fix this happening? How can we include some more columns? Well, very clearly there are some films here which have very long titles, so they're hogging quite a lot of space. So we can see that Lord of the Rings, all of the Lord of the Rings films, no hate against them, are taking up too much space. So what we can do is we can remove them by using the skip rows. So let's, once again, let's say short name films. That'll be our new variable. So only the films with the short names. We can also remove the good, the bad, the ugly, just to be a little fair. Pandas dot read CSV. Then, in this case, this is very important, indexing starts from 1. This can be kind of confusing. First, let's just get this directory in here, and then you'll see what I'm talking about. So, comma, we'll put in skip rows, equal to, put in our brackets. Now, indexing starts from 1, so that means we don't start from here, 0. We actually start, funny enough, from 1. Pay attention, do not pay attention to rank because it could change. These are just the columns in our CSV file. Instead, just add 1 to the index here, right? So we want to remove 5, 7, and 11, and also 9, right? So what we actually want to remove is 6, 8, 10, and 12. So let's go in here and input 6, 8, 10, and 12. Then let's just print it. Print our variable, that is, short name films, and hopefully we should have some more columns show up in the top section. Let's run that code. There we go. Only one column was excluded, and that was no ratings. We can actually do better than that. As you can see, the film with the next longest name is the Shawshank Redemption. So even though it's in the first position, we will have to remove it just to see if we can try and fit everything in, just for fun. So let's run that, and we still didn't get it. Okay, let's remove The Godfather Part 2. Okay, that's in position number 4, so we'll just add that in here. I really want to see this column on the right. Okay, there we go. Still no. Okay, I would keep trying, but it seems that no matter how long I go at it, I do not think I can get this column to show up here. So I think it's a good demonstration though of how this works. You can remove any one of these rows that you want. Of course, all of the data will remain the same. As you can see, the indexes that this creates, it creates a new set of indices ranging from 0 to 5 in this case, since we removed this many films. And as you can see, it doesn't change the rank. So the rank is no longer 1, 2, 3, 4. It skips over all the movies that we removed, all the films that we removed. Let's take a look at index underscore col, or index column. Let's create a code block here, and I'm going to try and explain this while doing it, because it's going to make a little more sense that way. So we're going to say movies underscore ranked is equal to pandas dot read CSV. Put in our file directory, pandas. There we go, pandas. Then we're going to put index col equal to, and I'm going to put 0, and I'll try and explain why now, okay? So print movies ranked. So when we created these variables here and we printed them out, as you can see, we have all the columns here and all the rows and everything, all our data, but we also have these indices on the left side here, right? That's the index column, right? What index col allows us to do, or index column, is it allows us to set one of these columns as the index itself, which is pretty cool. So I could, for example, index these movies not by an arbitrary number that we give them, but by their rank, for example, which could be pretty useful, right? Because if you want to get a movie based on its rank, these will not always line up with the actual rank of the movie. So, or these indices, right? So we can do something like this. Now, you should only use this when you know that each element of every row of this particular column is going to be unique. So that means no repeating values because indices need to be unique. You need to be able to access something via its index. So it needs to have a one-to-one relation with that element, right? So index call in this case, we're going to want to use the first column, right? So that's this one here. So let's print it and see what we get. Oh, there we go. Let's run that code. So now, as you can see, the index, there's no more column on the left with all the indices. Rank is our index column now. So we can actually access these values based on their rank. So that's pretty cool, right? That seems a lot more intuitive than using some arbitrary number. And this is especially useful when you have something like this. So these indices are not, it's not easy to tell which movie you're going to get from the index, right? Because this one is already a rank above, right? So you'd expect 0 to at least have the first one, right? But it doesn't. Then you'd expect, okay, 2 to 3, that makes sense. Okay, 3 to 4, no, because we're going to 5, right? So there's some discrepancies here. It's not a perfect relationship. But when we set this as the index, we can access them in a more intuitive way, which sometimes is what you want. It's something that makes more sense, right? So that's why this is quite useful. Let's head on to the next part here. So what does header do? Well, it's kind of unintuitive, but I'll try and explain it best I can. Let's create a code block and really quickly print our films variable so we can see it again. Now, what is a header? Well, this thing up here, that is essentially the descriptions of each of the columns. So rank, name, director, length, average rating, number of ratings, etc. Whatever it might be for your data set. That is basically the heading. Now, we can change that with a little piece of code called header. So when we're defining a variable, let's say we want films 1 is equal to pandas.read CSV, put in our directory, so the usual. Now comes the weird bit. Header equals, let's say none. Let's say we want to remove the header. What's going to happen? So let's of course also print it. There we go. And it seems at first that it has worked. We've removed the headers. They've been replaced by their indices. But if you look just one row below, you'll see that the header has actually been moved down to the 0th row. So if we want to really remove the header, we can do is we can use one of the previous parameters, which was skip rows. So we can skip rows and we can skip the 0th row, okay? Let's see what we get. So now we have an actual headerless data set here, or data frame. And as you can see, the ranks remain the same. So it's a little unintuitive, and you think, okay, that's a little strange. But let's say we want to make one of these entries here the header. We can actually do that. It is also a little unintuitive, but again, I'll explain everything. So let's copy this code here. And what we can do is we can change it to, let's say, the 3rd entry, or the 4th entry, 12 Angry Men. We want 12 Angry Men to be at the top, right? So 12 Angry Men is at the 4th position in terms of its index. Let's put that in and see what happens when we print films 1. Or perhaps let's make it films 2 now. So as you can see, 12 Angry Men is not the header, it's the first entry. Which you'd think, okay, that's weird, that's very strange, because now The Godfather Part 2 is the first entry. But if we go back, this is exactly what happened here, right? With our headers going down to the 0th entry. So what we can do is we can skip rows once more at the 1st position. We'll get 12 Angry Men as the header of this data frame, which is just, I mean, peculiar, very strange. So it's a little unintuitive and it takes some getting used to. If we want to rename the column headers for our data sets, all we need to do is use the names parameter. First, let's take a look at a new data set which has some purposefully long names that we want to shorten. We'll call it menu. That's the variable. We'll read the CSV, put in a directory, so /current directory. Then we want to access data sets /menu items.csv. Once again available in the description via our website or in GitHub. Let's print it. That's what it looks like, and cost to produce and cost to customer are very long column names, so let's rename them. We'll just copy this code. Bring it over here. Let's change this to short menu. We'll add in a comma, and we'll use in the names parameter, put in our brackets. We'll keep name the same because it's already quite short. We're going to change cost to produce to cost, and we'll change cost to customer to sale price or sell price. There we go. And we'll keep category the same. Now if we print short menu, we got names, not name. You'll see that while we do get the header with the shorter names, you must remember that it moves them down the original headers to the 0th index. How do we get around this? We use our good friend skip rows. We'll skip the first row, and there you go. Now, we need to check if we didn't accidentally skip anything important, right? So, of course we have the names here, but let's check the first entry, which is at the 0th position, cheeseburger, price of 1.25, category of food, which is there. How about fries? It seems to also be in the original, chicken nuggets, and I think we get the point. So, as you can see, all of the data is still there. And that's how you change the name. Let's take a look at dtype. What it does is it allows us to change the data type of one of the columns in our data set. So let's take a look at a new data set once again. Let's call the variable employees. We'll use pandas.read CSV, put in the directory. Now let's print it, see what we're working with. Don't forget the CSV at the end. And as you can see, we have all of these pieces of data here. Now, salary is currently being stored as an integer value. But salaries are not always a perfect round number, so we might want to store them as a float, for example. How do we change this? Let's copy the code here. Say employees is equal to pandas.readcsv, the directory, and then we're going to input dtype equals, we're going to use a dictionary here, and we're going to have key value pairs such that the value on the left, or the key, is the name of the column, so salary, and the value on the right is the new data type that we want to cast to. So in this case it's int, so let's change it to float. Then let's print employees, see what we get. As you can see now, each of these has a decimal point at the end of it. Now let's take a look at the functions, starting with head. So what this does is it shows us the first n rows of the data set. So let's take a look at our employees data set real quick. Now let's say we want just the first n rows. So I'm going to print employees.head. By default this is going to give us the first 5. There we go. Let's say we want to print the first 3. We can also have that. Let's say we want just the first. We can have that too. Now let's try tail. What tail does is the exact opposite. It gets the last n, or by default 5 elements. So let's use our students data set from before. And let's get the last 5 students. So as you can see, we get 1, 2, 3, 4, 5, right? Remember that the index is not the exact number. It starts from 0, so this would have been the 12th student. Now let's say we want just the last 7 or the last 3. So we can do both of those. Copy this over. And let's do this with perhaps menu items or short menu from before. So we can get the last.
Hello and welcome to aorbtech. Today we're going to discuss another episode of pandas, and in this episode we're gonna briefly discuss how we can handle missing values. So the agenda of today's episode: first we will work on now values, after that keep default now, then we will see a various operation in now filter and is null and not null as well, and in the last how we can work on drop now. So let's start with that. Before jump into practical part, let's discuss what does it mean handling missing value. Well, the handling missing value is mean that filling the missing values or fixing those missing values. In a real world, the raw data are incomplete, and it could be various reasons such as human error, system error. It could be also one of the reason, and also while collection they miss some points, and that's because of we are facing those missing values. So why we need handling missing values? When we're working on machine learning models, machine learning, we are make sure that quality of the data, if we are provide garbage data set, machine learning model will predict garbage prediction. So that's why we need to be make sure our data set is clean, and also make sure the quality of data, which will help us for the better prediction in the machine learning models. So don't worry, we'll discuss machine learning part in the future course, but for now we're going to discuss about pandas, because this is one of the element that we need to understand here. Now we'll jump into our practical part, and first we need to import our library, import pandas as PD. Now we'll go and discuss our first function, what is now value. Sometime pandas don't interrupt with the now values, so for that we need to manually type, and for that we are using now values. For example, I already import my data set pd.read underscore csv, already we discussed in our third episode, and I just simply call my variable which is data set. So if you see this data set, for example, and especially the column of location, area, square feet, and bedroom. So for example, you see those some of them values are missing. For example, this is also missing values, this is also missing values, and in price row 10 is also missing values. But if we see this one, this is also missing values, and we also see this one is also on missing values. But pandas only understand that our none are missing value, these are not. So for that we need to manually type that these are also our missing value. For example, name not available and no. So let's see how we can tackle these things. So let's say that I'm gonna take data set one, let's say that, and I say the pd dot read underscore CSV file, and there I will pass another parameter, and this parameter will be now value. So now values, and then I take a list and I will type this name. For example, my first one is this one, which is not available, and my second one is basically n double o, triple o actually. So now if I run my data set, and I can show you with the example. Okay, we have to say dataset, not dataset one. So now if I show you how now value is work, if we see especially bedroom row 6, and we can see previously row 6, you can find the differences. So we manually type that not available and no or our also a missing value. For example, not available is also negated as a none. So that's how we can handle those missing value which is not handled by pandas. So we need to pass another parameter which is now values, and in that we are passing those name. There's another way we can work to that. Instead of, for example, just taking a list and passing those value, we can write in the dictionary with the column name as well. So let me show you how we can do that. Let me take dataset 2, and I said that read underscore CSV file, and I said that dictionary, and first column that I will pass is my area, square feet. Yeah, so my first column is, as you know, that area SQFT, and I would say that not available, and price USD we would say that no. So, and then if I run, and that's also work. So yeah, that's how we can do that. So either you can pass a list and then you passing those value. For example, we have no not available, either you pass parameter now values. Inside dictionary you pass key values. Those key will be your column, and then you specify those value that is not handled by pandas, and then you can type, for example, in price USD we have no, and in the other column we have this one. So basically that's how we can work on this one. So I hope it's clear for you. Now we're gonna move our next function, and this topic is keep default now. So what does it mean, keep default now? By using this parameter, it will control how pandas treat missing value while reading a CSV file. For example, if I show you this data set, and in this data set we already have some missing value. For example, in price USD we have some missing values, then we also have missing value in bedrooms, then we have area square feet as well, we have some missing value. So when we run or use keep default no parameter, and it basically automatically interrupt certain string. For example, in that case we have a nan, it could be also possible na n slash a null and so on. So let me show you a practical, and let's import our data set. So the data set is like a pd dot read underscore csv. We already discussed this function very briefly, and then I'm gonna pass my data, which is dot csv comma, and now we'll pass this parameter keep default. Now if I say that it's false, and if I show you my data set, so do you see the difference? So well, so now instead of we have nan showing here, it basically showing nothing here. For example, it was some nan's value here. We reuse the same data set. This is the same data set. So when we keep default now is equal to pass false here, it will show nothing. I can show you another example. If we will pass true, it will show me with nan again. So as you can see that, so that's how we can work on keep default now. So simply just is basically, as I mentioned, that is basically automatically interrupt certain string like na, nan, and so on, and that's how it's work. We're going to move isNull. IsNull is one of the most important method that we used while handling missing value. So what does it mean by isNull? IsNull is basically return our data set in form of boolean. If the values are missing, it will tell that these are true. For example, in price USD we have like third row and ninth row we have a true and true, and the rest of them is false. So let me show you with example. So what was our name? I'm using this data set that I'll already show you here. So data dot is null, and if I run, so as you can see the results. So for example, we already seen our ninth row and last column, which is price USD, is missing, so it will show us as a true. So and this is also a true, it's true. So as you can see the results, if we have some missing value, it will tell us a true. It will not, then it will return as a false. So there is one more way. If I wanted to check by each column how many missing values are missing, so we can use dataset dot is null, and then I said sum. So what it will happen, if I run, I can show the results. So it will tell us that each column with respect to how many missing values. So for example, if we see here in the data set, in price USD we have two missing value, bedroom we have two missing values, area square feet we also have two missing value. We don't have missing value in location, we don't have missing value in ID as well. So as you can see that we can see that house ID and location we don't have any missing value, it show as a 0, and the rest of column we have each two are missing values. So that's how it work. If you wanted to see that how much total missing values, simply you just write data dot is null dot sum, again dot sum, and it will sum up of all the values, and it will return a result that we have a total 6 values are missing. As you can see that it will sum up of all the column missing value and then return the result. So that's how it work. Another one is basically not null. It's opposite way of is null. I can show you the example. So our topic is not null, and it should be not null. So not null, we have a data set. Let's say that we have this. Let me show you our data set first. Put into Python. So this is our data set. So not null is opposite, as I said that. So what I will say that data dot not null, and what will happen here, instead of returning true, it will return as a false. So as you can see that the missing value that we had, it will return as a false, which means that they are missing value, the rest of true are we don't have missing value. So if I show you in with the sum example, dot null dot sum, it will return opposite way. So for example, we have values, for example 10, which means that we, and then 8, so which means that we have 8 values here in this area square, feet, bedroom and price, and we have 10 values here in house RD and locations. If I take this example and sum up all, it will return how many values we had. It will return 44. Instead, in the missing values, for example is null, it returns 6, that we have a 6 missing value, but not null, it basically opposite way of is null. I hope it's clear for you. Now we'll see how the drop noise work. Very simple. It basically remove all those rows which are missing. So let me show you our data, and let's say that we have this data, and in this data we have some missing value. So now we'll use drop now dot drop now, and if I run, you will see the magic. It basically remove all of those missing value rows. So we have some rows which are missing, basically simply remove. So that's how the drop noise work. So in this episode our focus is more handling missing values. In the next one we will see how we can fill those missing values. So and so the last one, if I wanted to update my this data, I simply take this example for example, and I said that in place is equal to true, and it will basically update my data set. So if I, for example, if I run data here, it will show my all data set, but after updating, if I simply run my data again, it's already updated, so it will show me in this data set that I recently updated. So that's how it's work. I hope you enjoy this episode. In this episode we discuss various technique to handle those missing values. So we see how we can work on null values, and then we also see some filter method, then we see keep default now for example, then we see is null, not null, and in the last we see how we can drop our missing values.
And welcome to the 6th episode in the aorbtech Pandas series. Today we're going to be looking at the fillna method. In this episode we're going to be looking at how to fill by value. We're going to be looking at some fill methods, forward fill and backwards fill. Then we're going to be looking at changing the fill axis, so by column or by row. We're going to be setting limits for our fill, and we're going to be using in place. So let's get into it. Let's start by importing pandas, create a code block, and import pandas. There we go. Let's start with looking at what the fillna method actually does. Basically, if we have missing data inside our data set, what we can do is we can replace it with something else. That's what it does. That's something else, in this case, in this example being x. To demonstrate this, let's really quickly take a look at a data set. So we'll open up a CSV file. We're going to set it to the variable zoo. We're going to use pandas.readCSV. And I think this is a markdown. So let's create a code block. And let's just print it. Or let's view it real quick just to see what it looks like. There we go. So as you can see, wherever we have a missing value, we just have NaN, which is something that's recognized by pandas. If you want to figure out how to normalize this so that, for example, if you had a question mark here or something else that pandas doesn't understand, we have an episode on how to do that, and I think that's the previous episode, so you can go check that out. Let's go to value. So if we want to replace one of these, what we can do is we can simply replace the missing values with our own value. Maybe it makes it easier for us to see. So assuming we have a normalized data set here, let's create a code block. And what we're going to do is we're going to have zoo.fillna. That's the method we want to use. And then we're going to put in a value for x, right? So let's say we want each missing value to be replaced with the words missing value, and that'll make it really clear where they are. As you can see, every single value that we had that was previously NaN has been replaced with what we put in here, so missing value. We can also fill it in with a number, for example, if we want to. So we can put in the number 7. As you can see, we have missing values being replaced with the number 7. We can also do this using a dictionary. So let's create a code block here. Let's take a look at our zoo. As you can see, for each of these columns, we have different data types. For example, for animals, we're likely storing these using strings. And for daily visitors, we're likely storing these using doubles or floats. So when we want to replace missing values here with our own values, it's important to take into account what data types are present, right? So what we can do is, for each column, we can individually set what we want the missing value to be. And we can do that by using a dictionary with key value pairs, where the keys are the columns and the values are the values that we're going to replace with the missing values in our data sets. So let's demonstrate that. We'll have zoo use the fillna method, and then we're going to use braces to create our dictionary. And here is where the fun begins. So let's start with the animal column. If there were missing values here, we would like to probably replace them with unknown. Then we can create another key value pair. Let's look at daily visitors. And we want to replace any missing values there with 0. Then let's look at profit. If there were any missing values here, because the profit column has floats, we're also going to use a number. Okay, let's look at rating. That is also stored using numerical values. So we'll set that to 0 as well. And finally, we have opening year. And for this one, we're going to set it to, let's say, 2000 as a default value. And there we go. Okay. So now if we take a look at this, you can see we don't have missing values, and where there were missing values, they've been replaced appropriately with the correct data type. Except for daily visitors, which we need to spell correctly. There we go. So as you can see, where we had NaN, we now have 0. If we did have any missing values here, they would have been replaced with unknown. And finally, the opening year has been replaced with 2000, where it was previously unknown as well. We can also fill individual columns. So let's create a code block. Now let's say we want just to access this column, but we have this missing data here. Let's take a look at our zoo. So we have this missing data, NAN, and we want to replace it, let's say, with the median of the daily visitors. So we'll access zoo at the column daily visitors. There we go. Then we're going to fill NA. Then we want to have the median of this. So we once again need to access it, this column, and we're going to use the median function. There we go. Let's break this down really quickly. That was very quick. So we're accessing the column of daily visitors from the zoo dataset. That's this one here. We want to replace any missing values with the median. So first we want to replace missing values. We're going to do that with the fillna method. Then what we're going to do is we're going to access the column one more time so that we can take its mean, and we're going to do that with the median method. So now let's see what that looks like, okay? So as you can see, wherever there was NAN, it's been replaced with the median, which it appears in this case is 370. Okay, pretty simple. Let's say we want to replace the profit here with the mean. So very, very similar procedure. We're going to access the profit column. We're going to use the fillna method to replace the missing values with our own. And then once again, we're going to access that column because we want to get its mean. And we're going to use the method mean to get that value. And now let's check that one more time. And as you can see, every single value has been filled in. And it appears that at the 6th position, NAN, so this would be our mean, 287.5. We can also use the data that's already in our data set to replace the missing values. So there are two main ways of doing this. There are forward fill and backwards fill. So forward fill basically takes the previous data, be that column or row, which we'll take a look at how to do that later, but it takes a look at the previous data and it will pass that data into the next rows. Backwards fill basically does the opposite. As soon as we encounter a missing value, it'll look all the way forward for the next filled in value, and then it'll use that value as the value for the missing value. So let's take a look at forward fill first. And to do that, we're going to need a data set. So I'm just going to print it out real quick. There we go. As you can see, we have some missing values here. So let's take a look at what forward fill looks like. We'll do this by accessing our new data set, which is called weather.ffill. Then we're going to use parentheses, and let's print it. There we go. So now, of course. So now we have this data set here, and we can compare it to the previous one. So at position 2 we have an NAN, a temperature, and above it is 14, keep that in mind. So we'll go to this index here, and as you can see, both of these are now 14. Let's try and find another one. In the third row, in the humidity column, we have an NAN, above it is 82. As you can see, 82 is repeated here and here. Finally, let's take a look at the wind speed column. We have NAN in the first row and in the 6th. Above them are 10 and 22. As you can see, 10 is repeated here, and so is 22. Let's look at backwards fill. So we'll do the same thing here. Weather.bfill, parentheses, then let's take a look. Now it does the opposite. So let's look in the same places. Temperature column, position 2. NAN, below it is 13. 13 repeats twice here. Let's go up and take a look at the humidity column. Third position, below it is 85. And 85 is repeated twice. Finally, we'll take a look at the wind speed column, and this one's very important, so take notes. As you can see, in this position here, the first position, the first index, we have NaN, below it is 15, so we should see 15 twice. In the final position, however, we have NaN, which means that there is no position below it for our program to take the value from, or for pandas to take the value from. So if we go down here, as we can see, the expected result that 15 is doubled occurs. However, the bottom value is still missing. So just keep that in mind. This also goes for forward fill. If there is no value above it, let's say if we had NaN here at the very top of the CSV, then we would not be able to use that value below. So just keep that in mind. There are some edge cases where this will not completely fix your data set. So within backwards fill and forward fill, we can also change the axis. By default, it will be 0, which means that we will inherit from the column above or below, or the row above or below, within the same column. But we can also inherit data from the column to the left or to the right, depending on if it's forward or backwards fill. So we'll just skip over column here because it's the same as doing this. We'll go straight to row, and we'll say weather.forward fill, and then we'll change the axis to 1 and see what that looks like. In this situation, it's not ideal because to the left we have the date column, and obviously that doesn't work very well with the temperature column where we have float values. And if we were to do backwards fill, with axis being 1, we will have a similar issue over here, where we inherit from the weather column in the PM 2.5 column, which also uses float values. So as you can see, we have a string in the wrong column. So it's just a different way of doing the same thing, but keep in mind that depending on which data set you're using, this will be more or less useful. Now we're going to take a look at limit. And what this does is it specifies the maximum number of rows per column which we can fill using fillna. So let's really quickly take a look at a new dataset, flights, assign it to the variable flights, and see what it looks like. So as you can see, we have a number of missing values in the passengers column here. We have 1, 2, 3. So let's really quickly use flights.fillna, and what we're going to do is we're going to set the limit to 2 and see what that looks like. And of course we need to have a value that we're going to replace it with, so let's just say missing. Don't forget the comma. And there we go. So these first 2 values in the passenger column have been replaced with missing, as have the other missing values, except that since we have 3 missing values in the passengers column, the third one is not replaced. It is replaced with NaN. And let's try doing that as well with 1. So copy that over. As you can see, only the first missing value is replaced in each column, which means that for the passengers column, there are 2 missing values. For the departure time column, there is 1 missing value. And for the plane type, there is also 1 missing value in this row. Let's also take a look at in place. So what this does is it allows us to specify if we want to create a new data set when we use the fillna method, or if we do not. So what we can do here is we can say passengers flights dot fillna, we'll say missing, and we'll set in place to true. Okay, and now if we access flights, we see that all of the missing values have been replaced. Now, if we take a look at a previous data set, which we have not changed, we'll see that the values here are still NaN. So this is what it looks like now. And let's just try to access it one more time. This time, as we did with flights, we're going to set in place to true. So su.fillna. going to replace everything that's missing with the word missing, and we're going to set in place to true. And then we're going to access it just to see what we get. And as you can see, it is the same variable that we called previously, except that since we used in place equals true, we didn't create a new data set, but we actually replaced the values in the original data set, as you can see. And that's the end.
Hello and welcome to aorbtech. Today we're going to discuss another episode about Pandas series, and in this episode we'll briefly discuss about replace value. So the agenda of today's episode: first we will discuss how we can replace value with the existing value in our data frame. After that we'll see regex, and then we'll see a couple of methods such as forward fill and backward fill. And second last, we'll see how we can apply a limit function. And in the last, once we apply all of those methods and function, then we use in place to update our dataset. Before going to practical part, we need to understand what does it mean by replace value. Well, replace value is basically changing existing values in a data frame or series with the new values. So for example, if you wanted to replace some values in your data set, you can use replace functions. Let's start with the practical. First we need to import our library. I already upload and import pandas as PD, as we already know. Why pandas is used here to import our data set, also for data analysis and data manipulations. And the second one we will also used, we already make a complete course on NumPy. If you didn't watch it, feel free to visit this course to understand how NumPy is work. Here we will use a small function for the non-values, and don't worry, I will make example, a brief example to explain you further on that. So I'm gonna use house price dataset. We already know that pd dot read underscore, if you wanted to read CSV file, that you using read underscore CSV function to import our data set. We already discussed in our third episode about that. So let me show you about my data set. This is a very small data set that we will use for this replace value episode. So this data set is about 5 column: house ID, location, area square feet, bedrooms, and last one is basically price USD. So now we will use our to replace function, how we can replace our value. So let's say that I wanted to replace city center with the city, let's say that. So how I can do that? So simply you have to call your data set, then you say that replace, and then you basically to replace with, for example, I wanted to replace city center, let's say that. And I wanted to replace it with, let's say that, value. So I wanted to say that my value will be city, let's say that. So if I run, and as you can see that we replace our value city center with a city value. So if you see our previous data set, we have a location column where we have a city center, so we replace city center with simply city. So as you can see that city center is split by city, then another one and another one. If the city center also existing in another columns, this will also applies, because we didn't mention here any column, we just mention values to replace with random values. So I will show you another example. For example, if you see our data set, we have some nan values, as you can see that basically these are represent as a missing value. So let's say that I wanted to replace those nan values with 0, let's say that. So how I can do that? Same dot replace, and I wanted to replace, let's say that to replace nan np dot nan value with a 0, and if I wanted to run my this line of code perfectly, as you can see that we replace nan value with 0. So this is applies to other column as well. For example, as you can see that this also apply here as well, this is also apply here as well, this is also apply here as well. So that's how you can use replace method. There's another way you can do that. Instead of writing to replace comma value, you simply say that np dot replace, let's say that I wanted to replace 950 with 980, let's say that. So I would replace 950 with 980, and let's run. So as you can see that 952, which is our third row, is replaced with 980. So instead of you write to replace comma value and then you mention those value that you want to replace, simply you just replace your value with the existing value. So the first parameter here will be represent the value that you wanted to replace, and the second value, the value that you wanted. For example, you wanted 980 with replace with 950. So that's how it's work. So let me show you another example. Let's say that let me show you my data set. So let's say that I wanted to replace nan value in bedroom with 3. So instead of nans, like for example price USD or area square feet, but if I apply np.nan, it will apply all of those columns where those are missing values. So how I can apply only specific column? So let's see. So let's say that I wanted to take data frame, and I say that df, and I would say that df simply I wanted to say that my bedroom, and I wanted to replace the bedroom column np.nan with 3. So if I run my data frame and I show you, this is how I replace with a nan value with 30. So I need to call my data set again, and I wanted to show you this example. So because I'm updating only my a bedroom column, not all the columns, so I need to mention here my bedroom column that I wanted to update, because I am replacing only bedroom here. So here it is. So if you see the example here, in bedroom we don't have any nan values. If you see our data set previously, like original data set, we have some missing value, but we replaced with 30, and the rest of price, USD, and the area square foot, we still have a nan value. So that's how you can use replace method to replace a value. Either you can replace with existing value, either you can replace with the missing value. You can apply with all columns, or either you wanted to apply with a specific column. So I hope it's clear for you. Now we'll move to another topic, and this topic is regex. So regex is basically regular expression used to replace the specific characters in a string. For example, you wanted to replace city center with city main center. So how we can do that? Or you wanted to do that, replace S with double S, or you wanted to replace rural with RR. So how you can do that? Instead of writing rural replacing with double R URL, you just write R replace with double R, and then you pass another parameter which is regex. So let me show you example. So let's me show you our data set. So this is our data set. So let's say that I wanted to replace with let's say that rural with RU double RL, let's say that. So how I can do that? So simply same as before, and first value that we wanted to replace, let's say that I wanted to replace R with let's say that double R, and simply you pass another parameter. By default it was false. So if you wanted to replace specific characters, then you need to turn on, like for example true. So if I run, and if you see some differences, so basically R is replaced with double R. Instead of writing rural or what was suburb, or for example city center, it replaced with double R. So that's how regex is worked. I'll show you another example. So let's say that I wanted to replace 1 with one, so I can do that. So let me write our code, replace, and I wanted to say that 1 is replaced with 1, right? X is equal to 2, and if I run, if you see H1 is replaced with one. So maybe you have a question in your mind, why this one is not applied. For example, one is replaced with one, and so on. So as I said that regex is only applied with the string values. It's not applied on the float or integers values. So I can show you my the type. So if I wanted to show you my data type, and if you see, our first two column is basically object, but the rest of three column is basically float. So the regex is equal to true is only applied in object column, so that's why 1 is not replaced with one because it was float value, and we are basically mention here in the string, so that's why it's replaced with this one. Let's say that I wanted to with 1 with 1, it will not applied because this is applied only a string value. So that's how we can use regex is equal to true. So let me show you a quick example. Let's say this is our data set and I take this example. Let's say that and instead of passing true, I would say that false, it will not apply it because regex is false. So yeah, that's how the regex is work. Now let's move our next topic. Now we'll discuss a couple of methods such as forward fill and backward fill. So this is how we can use forward fill. Simply, if I see the definition, replace previous value with the forward value, and backward value is basically replace forward value with the previous value. Don't worry, we will try to demonstrate in the practical. So let's say that df dot replace, and I wanted to replace rural with the f fill, like forward fill. So how I can do that? So simply you just mention your value that you wanted to replace and you use forward fill. Well, so you simply write method and it will basically replace forward value. Don't worry, this is just was feature warning. So if you see our rural, let me show you the data set. Maybe it was our region data set. So if you see rural, which is in our third row, so rural is a place with the suburb, and if we see another one, this is also replaced with suburb, and if you see rural, it's replaced with city center. So we use forward fill method to replace with rural with value. So if I show you backward fill, how I can do that? So this is my data set and I said that I wanted to replace, let's say that city center, or maybe I wanted to replace with h4. So I can do the df dot replace. So first one, the value that you want to replace, and let's say I wanted to use backward fill. So if I show you my example, so h4, this one is basically replaced with h5. You see the definitions, replace forward value with the previous value. So simply h4 is replaced with h5, and if I take this example, what will happen here? So basically this super will be replaced with a rural, or I wanted to replace city center instead of suburb it will replace with the rural value. But if I use let's say that forward fill, it will replace with suburb. So that's how forward fill or backward fill is work. So let's say that we have our couple of nan values and I want to replace with the forward fill values. So let's say that how I can do that. So simply f dot replace, and I wanted to replace np dot nan, and I wanted to replace with forward fill. So here nan is basically replaced with 180000. Here it will be replied with 19000. Then this one is replaced with 2000, and nan will reply with the 1600. So how we show with the example, and as you can see that if you see our data set and it replaced with 16, it's also replaced with 18 like forward fill, and it's replaced with backward fill with 19. So that's how the forward fill and backward fill is work. It's very handy when you have a missing values and you wanted to replace nan with method like forward fill or backward fill, so it basically replace with your previous or forward value. So that's how this method is work. So the last method is basically in place. I can show you, we already discussed in the last episode as well. So if I show my data set, this is my data set, and I apply some, let's say that forward fill method, replace nan value with forward fill values, and this is my new values. But if I run df again, it will show my original data set. So how I can replace? So simply just pass another parameter, which is basically in place is equal to true, and now if I run, it's basically update my new data set with the old data set. So that's how in place is work. I hope it's clear for you. So that was the end of our episode. We briefly discussed replace value, then we'll see a couple of method, and in the last how we can update our data set.
Hello everybody, and welcome to the 8th episode in the aorbtech Pandas series. Today we're going to be taking a look at the interpolate function. We're going to be taking a look at interpolation methods, including linear, nearest, polynomial, and working with time. We're going to be taking a look at limits, including limit direction and limit area, and then we're going to be using in place. So what does the interpolate function do? It fills in missing numerical values in your data frames by estimating them based on existing data. What does this mean for us? Well, it means that for our data sets, we'll be using numerical values within our columns. Just some footnotes. You will need to pip install scipy for some of these functions to work correctly. And these are mainly the methods that we're going to be using. Nothing too difficult. You can do it in the console, you can do it in your environment by using exclamation mark pip install scipy. So we're going to import pandas, and then we're going to import our data sets. And one footnote to mention is that for the second data set, the machine data set, we're going to add an additional argument here called passDate with the time column. And what we're doing here basically is in this data set, we have a column in a specific format that has all of the date time values. And what we want to do is we want to convert those to date time values so that we can use them in our testing. We also have to use this over here. And this, what it does is it sets the time column that we've just formatted as the index of the data set. So that will also help us use it in our testing. So just make sure you do that, and if you're having any issues with the time method, this is probably why. So let's take a look at methods. What we're going to be focusing on in this episode is filling in missing data using other data that we have. Now, there are a bunch of different ways that we can do this, and here are the methods that we're going to be looking at in this episode: linear, nearest, polynomial, and time. And what these do are they all have different ways of filling in that data. And we're going to be exploring that shortly. But first, let's take a look at what our data sets look like. So let's take out revision. That's our first data set. And then machine. And that's our second data set. And that's what they look like. Let's take a look at the linear method. Now, this is actually the default method when using the interpolation function. And what it basically does, let's take a look at our data sets here to explain this. It looks at the missing values in our data and it ignores the index. So this doesn't have anything to do with how it's going to fill in the data. It takes a look at the missing data, which is surrounded by data that is not missing. So for example, this section here. And it fills in the data according to, let's say we start at 72 and we end at 77, right? So we find the two values that fit in between, and then we'll use those values to fill in these missing values here. That's essentially what it does. So let's try it out. Let's create a code block here. First of all, let's take revision. We're going to use the interpolate function. And we don't have to put in method equals linear, and we'll see what that looks like real quick. There you go. So these missing values here have been filled in. So the two values between 72 and 77, for example, as have the others. But what we can also do, let's say we take our machine data set. We can also set the method to linear. And it will work just the same. So you don't have to put in method equals linear. It is the default. But if you want to be specific, then that's what you can do. And just to compare these, let's create another code block here. What we should see is that the values here that are filled in are the same. Let's go up here. So 73.6, that's what we get, and 75.3 recurring, also what we get. So these two are identical ways of interpolation. Let's now cover the nearest method. Really quickly, let's take a look at our data set once more. We'll start with revision. And what this essentially does is it takes a look at the values that are missing and the values nearest to them. And using the values nearest to them, it will fill in those missing values. So to see what that looks like, let's take revision once more, interpolate, set the method to nearest, and see what that looks like. So over here, indexes 2 and 3, we had these missing values. Above this missing value is 72, and below this value is 77. Those are the nearest values to each of these. And if we look down here, we can actually see that the missing value here has been filled in with 72, and the value below it has been filled in with 77. And if we take a look at another pair of values, for example, these two here, in the 4th and 5th column, or row, we can see that they have also been filled in with the nearest non-missing value. Let's take a look at polynomial next. So the polynomial method essentially analyzes our data and it tries to fit a polynomial, so a curved line essentially, to fit our data best it can, so then it can estimate the missing values based on that. So this can be of order 2 or 3 or above, but one caveat that you have to consider is that for it to be able to do this, it needs quite a bit of data to analyze to be able to make a good estimation. So let's try and see what it does to our machine data set. So there we go. Let's let's try and focus on this area here, since we have quite a few consecutive missing values here. So we'll use machine.interpolate. We'll use the method of polynomial, and we'll set the order to 2. This can be any integer that you like. And let's see what it does. So as you can see here, it fits the data according to what it's analyzed to be the best way to fill this in. So it goes from 32 to 35, and it looks like it goes up a little bit, then down, and then back up again. And we can also try and do this with a higher order function. So interpolate method equals polynomial. Let's see what that looks like. 232, then it goes 232.2 roughly, 232.4, and then up 234.2 roughly, and then 235. So quite a smooth curve again, and you can keep going up. I'm not sure if this data set works for order 4, but I suppose we could try it. Oh, and it does. Okay, so this fits a 4th order polynomial function to our data set, and it estimates the missing data based on that. So let's see this once again. And so this goes up, back down, up again, and then back down again. So this really depends on your data. You will need to sort of figure out which order polynomial will best fit your data. But that's how you use that. Finally, moving on to time, and this one we will have to make sure that the time in column is the index, and also make sure that it's formatted correctly, as we did in the beginning of the episode. And for this one, we can only use the machine data set, because that's the one that we formatted to be able to do this with. And what this does, essentially, is that, remember at the beginning of the episode when we mentioned that for the linear method, it did not take the index into account when calculating the data? Well, with the time method, it actually does take that into account. So it looks at the data set, it looks at the difference in time between all of the pieces of data, and then it finds where that data would be on that timeline, basically. So it's a lot more accurate when you're using time interval based data. So let's really quickly take a look at machine once more, and we'll now use the time interpolation method. So machine.interpolate method equals time, and there we go. So we can check out any of these areas. Let's say this area here. So we have a jump from 3 o'clock to 6 o'clock to 8 o'clock, or almost 9, 8:56. And you can see here the data is not filled in linearly, but there are differently sized jumps from one bit of data to the next bit of data. So over here, for example, we only moved up by 0.14 because the jump from we've got a jump from 2:45 to 3, which is only 20 minutes. 3:05, sorry. But then we've got a bigger jump here, so from 3:05 to 6:21, and as you can see, the jump in the values between these two values is actually quite large compared to the jump between these two values. So it just takes that into account. So let's say we want to fill in data in our data set, but where there are big gaps, we don't want to estimate all of that, because that can lead to inaccuracies. So what we can do here is we can take a look at our revision data set, and for this we're going to use limit, and limit allows us to basically set, okay, let's say we have a gap of 3. I don't want to fill in all of those, just fill in 1. Okay, so what we would do is we would use revision.interpolate, so we're going to interpolate it, and we're going to set the limit to 1. Now, before we run this, let's take a look at our data set real quick. We have a number of missing values here. So we've got a gap here with 2 missing values, another gap here, and another one here. And so it's going to take a look at all of these gaps, and it's going to only fill in one. So for example, in this column here, we have a missing piece of data here, and another missing piece of data here, but it's only going to fill in one of them. And another piece of data here, but since this one is alone, it will fill that in. So let's run this and see what happens. So as you can see, where we have large gaps, where we have initial data, missing data, it will not fill that data in. However, where we do have data with which it is surrounded by enough non-missing data that we can interpolate it from, or that we can use that data to estimate, it has done so. We can even set the limit to 2 and see what that looks like. And as you can see, that's what it's done. So let's really quickly try and take a look at what this does to a machine. And as you can see here, we have 3 pieces of missing data. So what we can do is we can do machine.interpolate, and we can set the limit to 2. And as you can see, there is still a missing value here. We can also set this to 3, and now all of those values have been filled in. We can also set a limit direction. And I think the best way to demonstrate this is simply by printing out our data, so like so, and then using this method. So vision.interpolate limit direction equals, and now we can choose from any of these. Let's start with forward and see what it does to our data. So we have this missing data here. Now, whenever we go forward from the top, we can take a look at the previous data and we can use that to fill in the next data. And if we were to do this with backwards, this is what we would get. So notice that this missing value here has been filled in now, and this one has not. What we're doing basically is the opposite of what we were doing before. Instead of going from the top of the data down and then basing it on the data above, we're actually going from the bottom and basing it on the data below. So in this case, over here, there is no data below this missing value to interpolate with, so we can't estimate that value. But actually, where we had a missing value here after interpolation, we no longer have that because we have a value below for it to estimate that value with. What we can also do is consider both directions. So we can interpolate here. And we set this to both. As you can see, all missing values have been filled in because we're not only taking a look at the values below or the values above, but we're taking a look at both. So even the values on the top and the bottom have been filled in. When we're trying to estimate data inside of a data set, or when we're trying to estimate data based on the data inside of a data set, that's called interpolation. That's what we've been doing. When we try to fill in data outside of the data set based on information from the data set itself, that's something called extrapolation. And we can actually do that with this function as well. We're going to have to use something called limit area. So what we can do here is we can take a look at our machine data set. And as you can see, we have some data on the outside, which doesn't have any data above it or below it. So for example, this piece of data here doesn't have anything below it, but it's on the edge. And we have some data on the inside. So all of these missing values here are surrounded by other values that are not missing. And this one as well, this one here, this one. There are plenty. These ones here, for example. So If we want to specify that we don't want to extrapolate data, we only want to interpolate data, what we can do is we can set the limit area to inside. Let's try interpolating using that principle. There we go. Now let's see the effect of that. In machine we had two outer missing elements. This was this one here and this one here. Once we set it to inside, so only interpolation, all of the missing values on the inside have been filled in. But what if we want to fill in the missing values on the outside? And there is a little quirk to this as well. So you'd think that we can just do interpolate with the limit area equals outside. And this does work. This does fill in missing data on the outside. So it does extrapolate. However, there is a little quirk to notice. So first of all, let's point out that all of these inner missing data, pieces of data have not been filled in. But the outer pieces of data have also not been filled in. This one has, but this one has not. So this is just a quirk of pandas. What you will need to do is use something that we've used before. What we can do is set the limit direction to both. There we go. And now, if we try this, both of these pieces of missing data will be filled in. There we go. We can also try this with revision. So let's first see what it looks like. And then let's interpolate it. First on the inside. So interpolation. And then we'll copy this code to make it quicker. And look at what it looks like on the outside. And let's not forget to put the limit direction to both. There we go. As you can see, we have two pieces of missing data on the outside here that have not been filled in. And here, they have been filled in, whereas the inner data, which was filled in here, was not filled in. Finally, let's look at in place. So, essentially, everything we've been doing in this episode doesn't actually change the original variable. You can see I've been using the same variable throughout all of these. So revision.interpolate, and it uses the original data set that we had, right? So if we want to change what the data set looks like, we can do something like this, and we'll use in place. That's what in place does, is whatever changes we make will be saved to the variable instead of creating a new variable. So let's take a look at revision. This is what it looks like, right? This is what the variable looks like, the one that we've been using this entire episode. Next, let's interpolate it. So exactly what we've been doing this whole time. And this is what the interpolated revision variable looks like, or the data frame, the data set. But if we take a look at revision again, the original variable itself, it actually hasn't changed. It doesn't look like this. This is what it looks like, right? So if we want to change what revision looks like, what we're going to have to do is interpolate it, and then we're going to use this over here in place. We're going to set it to true. Okay. And then we're going to take a look at revision. So maybe let me create a new code block. And now the variable has changed, whereas before, when we tried to take a look at the variable by itself before interpolation, it did not change. It was the same as it was before, as you can see. So after we interpolated it with in place, it actually changed the variable itself instead of giving us a new variable to look at.
Hello and welcome to aorbtech. Today we're going to discuss another episode of Pandas, and in this episode we will briefly discuss iloc and loc. Now let's move to a theoretical part. First try to understand the concept of iloc and loc. After that we'll move forward to a practical part. So if we see the basic definition, loc and iloc are two powerful indexers used to select data from a data frame. For example, if you have a data set about house price and you wanted to select some columns or you wanted to select some rows, you can do that by using loc and iloc. So loc and iloc are working basically same, but the way of implement is different. So let's move first. Loc is basically using label based indexing. So for example, if you wanted to access or select some columns, you can select them by typing their names. So let's see the practical part. First we need to import our library, as we already know that we're using pandas libraries, and so simply import pandas as pd. After that, I'm basically importing my dataset dot read underscore csv. Basically I'm trying to reading my CSV file, and we're using house price data. This dataset is quite small. I can show you the full data. Just basically we try to understand the concept. So we have basically 10 rows and we have 5 columns. So let's see how we can use loc. So let's say that I wanted to select all the rows and only price USD. So how I can do that? So df dot loc, and you already may be familiar with indexing. We already discussed in Python tutorials. If you didn't watch, or feel free to watch it. It will be better to understand how the slicing and indexing work. So I just wanted to take all the rows, so simply I just type and taking all the rows. Now I wanted to select price USD. So how I can do that? I simply, the first basically parameter here is basically selecting your rows, and the second one after comma, it will be your second parameter, which is basically selecting your column. So let's say that I wanted to select only price USD. So I can do that simply, as I said, that you just type the name, and if you run it, and you can see the results. We select price USD and we take all the rows. So let me show you another example. Let's say that I wanted to select for example until 5. So how I can do that? Simply df dot loc, and then you have a square bracket, take all the rows till 5, and then let's say that I wanted to take, for example, location ID, house ID, location, area square feet, and bedrooms. So how I can do that? Simply you have to say ID. You simply basically type, let me see, the it's basically capital, house ID. So house ID, and then you have basically area square feet, then you have location maybe, and then last one you're basically taking bedrooms as well. So I'm going to bedrooms, and if I run, let's see the results. So maybe one thing came to your mind, that our data set is basically, first we have a location ID, then area square foot, but after loc, like indexings, we are in our data set we have area square feet first and then location, because we write here area square foot first and then location. So whatever you write in the index parameters, you will get the results the way that you write. So let's see how this is work. So first we take our rows from 0 to 5. After that we comma, and then we create a list, and inside list we pass our column information. So for example, house ID, area square feet, location, bedrooms. So that's how you can do that. Or for example, I can show you an example. Let's say that my rows will start from 1. So instead of 0, I will just type 1 to 5. I will show you, and here you can see that we take from 1 to 5. We have the column, for example, house ID, area square feet, location, and bedroom. So that's how we can use log. So there's one more thing I want to discuss here. So let's say that I wanted to take the same line of code, and I wanted to take the row, for example, 1 3 5 7 9. So how I can do that? You also pass the list here, and then inside list you will basically pass the row that you wanted to use. For example, 1 3 5 7 9, and let me run this code, and as you can see that 1 3 5 7 9. So here we pass two lists. The first list is basically the rows that you select, and the second one is basically the column that we select here. So basically we did a random choice here, like not random, the way that we wanted to select. For example, we wanted to take only 1 3 5 7 and 9 rows, and we wanted only house ID, area square feet, location, and bedrooms. So that's how you can do that. If you wanted to take only one column, you don't need to pass into the list. You simply call as I did in price USD. And if you wanted to take 2 or 3 column, then you need to pass inside the list. I hope it's clear for you. Now we'll move forward to our next topic, which is iloc. As I mentioned, that the way of iloc is working same as it in loc, but we will implement a different way. So in loc we already see that we are basically choosing our column by labeling their names. For example, I mention here house ID, area square feet, location, and bedrooms. But in iloc we will use indexing approach, the same like way that you're doing slicing in Python. So let me show you with an example to understand you better. So let me call my data set. This is our data set, and I wanted to say that I wanted to take all the rows but the last columns. So how I can do that? So simply uses df. Instead of loc, you mention that iloc. After that you basically take all the rows, so we don't need to mention any length of here, and then I wanted to take 0 1 2 3 4, so simply you call 4. So if I run, you will see the results that we take our price USD. There's another way you can do that. I can show you. So instead of taking, you can also take -1. As you know that from the reverse, it's from -1, -2, -3, -4, and so on. So if I take -1, you will get the same results. So this is a two different way you can select. We'll discuss very briefly the slicing concept in Python, also in NumPy as well, so feel free to watch those videos. So as you see that we are using here index approach here instead of writing their name. So for that you just basically define your method or function, which is basically iloc, and then you passing your index value. Let's say that I wanted to take this same example. Okay, but I wanted to do with the iloc method. So how I can do that? I wanted to take area square foot, house ID, location, bedroom. So let's try to implement this method. Let me call my data set to see the name of the, sorry, it should be dot, and then I would say that head, and okay, this is our data set. So I wanted to select, for example, house ID, location, area square foot, and bedroom. So I can do that simply df iloc, and I want to take all the rows, and then I wanted to take, for example, I want to take 1, 2, 4. 4 will be excluded here, and if I run in wallet syntax, okay, so you just don't need basically square bracket here if you're slicing. So that's how we get. If I wanted to select my 0 column, my length will be start 1, so here also. So as we already know that index is started from a 0, it will not start from the 1. That's why when we passed 1 here, we are taking column from location, area square foot, and bedroom. So we are basically selecting here house ID, location, area square foot, and bedroom. We are basically skipping our price USD. 4 is our exclude, so that's why how we get the results here. Let's say that I wanted to choose location and bedrooms only, and I wanted to take first 5 rows. How I can do that? So locations and bedrooms. So if we see our data frame, location is at 1 index and bedroom is at 3 index, so 1 and 3. So how we can implement these things? So df dot iloc, and I wanted to take my 5 rows, and I wanted to take only 1 and 3, and if I run it, I get my locations and my bedrooms, and we have select 1 to 4 was excluded. So as we know that if we want to do 1 to 5, we need to times 6 here, so we'll get first 5 rows only column which is basically at 1 index and 3 index, which is location and ID. So that's how the iloc is work. I hope it's clear for you. A very simple and easy way that you can implement those methods while selecting your data from data frame. So you can choose any technique, it's up to your choice, but as I mentioned that the way of implement is different, but the way of working is completely the same as in loc or iloc.
Everybody, and welcome to the 10th episode in the aorbtech Pandas series. Today we're going to be looking at the GroupBy function. We're going to be starting with just GroupBy, and then we're also going to be looking at setGroup. This is going to be a pretty short episode. In this episode, we're going to be looking at the GroupBy function and setGroups. So what does the GroupBy function do? Well, it's in the name. It allows us to take the data from our datasets and put them into groups, basically. So let's start by importing pandas, of course, and importing our datasets. There we go. So to understand how this works, we're going to really quickly take a look at our most basic dataset. There we go, students. And we're going to separate the students by their sex. So let's create a new code block. We're going to say students dot group by. Then we're going to put the name of the column we want to group them by, so in this case sex. And then we're going to access it via using dot groups. And if we take a look, as you can see, it's separated them into the females column and to the males column. And inside here, we have the indices of all of those students. So let's take a look at the first 2 of each. So for example, at index 0 and 2, there are female students. So 0, we've got female, and 2, we've also got female. And then at indices 1 and 3, we have male students. So index 1 is a male, index 3 is also a male. So now that we know how that works a little better, let's try and access the second data set that we have, which is language learners. There we go. Now, let's try and separate these by the language that they speak. So we're going to say language learners.group by, and then the name of the column, so language, just language, and we're going to access the groups. There we go. So we have, it seems, 3 people learning Arabic. We've got a lot of people, these indices, who know English, or who are learning English. We've got 4 people who can speak French or are learning French, 3 for German, 2 for Italian, just 1 for Japanese, 4 for Spanish, and 3 for Urdu. Okay. Now let's try grouping them by how many years they've been learning that language, or how many years they've been speaking it. So language learners dot group by, then we're going to say the name of the column, which is years practiced. Okay, years underscore practiced, and then groups. Here we go. So this is just a bunch of numbers, but it seems that there's 1 person who's only been learning for a year, 2 people who have been, or 4 people who have been learning for 2 years, 4 people for 3 years, 3 people for 4 years, and so on. Now let's see if we can group them by their language level. So language learners dot group by level dot groups. There we go. So we have 5 people in the A2 bracket. We have a lot of people in the B1 bracket. Same goes for B2. And only a few people in the C1 and C2 bracket, with seemingly no one speaking A1 in the data set. What we can also do is we can apply some transformations to this data. So, for example, let's say we wanted to take a look at each language and how many years practiced it has on average. So what we could do is we could say language learners we want to group by language. Within that, what we want to access is years practiced, and we want the mean of that. There we go, that's the function. That was pretty quick. Let me explain that. So what we're doing is we're grouping the language learners data set by the language column, and within those groups we're accessing the years practiced column. So that's giving us all of the years practiced that each language has, and then we're gonna aggregate that into a mean. So we have the mean of all of those years practiced, and if we take a look at that, this is what we get. So each of these languages has a mean amount of years practiced. So for example, Arabic has 3.66, and what we can do as well is we can round this so it's a little easier to read. So Arabic has 3.67, English has 9.14, German has 7.67, and so on. We can do something similar to check the relationship between the level of the language and how long you've practiced. And what we would assume is that the longer you've practiced the language, the higher level you're going to have. So let's test that hypothesis. Let's take our data set, so language learners. We're going to group by the language. Oh, there we go. Within that, we're going to access we're going to group by the level, and within that, we're going to access the years practiced, and we're going to take the mean, and of course, we're going to round it again to 2, and let's see what it looks like. So actually, it's quite consistent. So for A2 level, 2.2 years on average. B1, 3.62. So it seems that they're increasing. C1, so to get from C1 to C2, 2 years based on the data set. So it seems to be consistent with what you would expect, which is pretty cool. Another interesting thing we can do is we can take a look at every name or every person and how many languages they speak. So we're going to take our data set, language learners, group by name, and we want to access the language column. So this will give us a group, or it'll group our data set by the people. Within that group, we're going to access the languages they speak, so the language column, and we're going to use the sum function here. And this will give us, maybe we can use the count function. There we go. So this will give us not an aggregate string of every single language they speak, but it will give us the number of languages they speak. So it seems that Alice speaks the most languages, so a very, very driven individual, with a couple of people at close second, and then Emma and Frank speaking the least languages at 3 each. So getGroup is another function that will let us kind of separate these groups and find out which one of them share certain values in common. So let's create an example by first creating a group. We're going to say languages, and then we're going to set that to our data set dot group by the language column. There we go. And what we're going to want to do is languages dot, we're going to use the getGroup function. And let's say we want every entry in which someone speaks the language English. There we go. So now this is going to give us every entry with an English speaker. So let's extend this idea and see if we can get every person at the C2 level. So the top speakers, the top achievers. So what we're going to do is we're going to create a new group. It's going to be called levels. We're going to take our data set. We're going to group by, there we go, and we're going to group by level column. Then we're going to take that new variable and we're going to get groups, or get group. And we want to access the group at level C2. There we go. So we have 3 people who can speak C2. Those are English, French, and German. So those are the highest level. We can do something similar here. We can access the level, let's see what's the lowest level. I believe it's A2 in this data set. So there are 5 people learning languages from the very beginning. So that's Alice, Bob, Carol, Emma, and Grace. And these are languages that they're learning. Okay, finally, let's see how many languages. Well, let's try and separate this by the people. So let's take our data set. We'll create a variable called people. We'll take language learners, group them by their names. Then we're going to take that group. We're going to apply the getGroup function. And we're going to want to group them by a certain name. Let's start with Alice, because she seems to be a very high achiever in this data set. So we can see here all of the information about Alice. Now let's say we want to learn about David. So we can just take this same command and put in David. Now we have all the information about him and the languages that he speaks. So maybe we can see what they share in common. So it seems they both speak English. They both speak Spanish at the same level as well. They do not both speak French, but they do both speak German, and they both speak Arabic as well. Okay, or at least they are learning it.
Hello and welcome to aorbtech. Today we're going to discuss another session about Pandas series, and in this session we'll briefly discuss about merging function. So agenda of today's session. First, we'll see the definition of merging function and try to understand how it's work. Then we'll understand the parameter that will pass inside the merging function. For example, left right, after that we'll work on, and then we'll see a different method such as inner outer, then indicator, after that we'll work on index, and last we'll see suffix. Now we'll see the definition of merging function and try to understand how it's work. So merging function is basically helping us to combine two different data frame based on the common column. So if I show you the wheel representations, let's say that this one is our first data frame and this one is our second data frame, and we have a common color is yellow, for example common column, and we combine or merge based on those common color here. So as you can see, yellow one, and we have a data frame 1 and we have a data frame 2, so we combine based on the common column two different data frame. So I hope it's clear for you. Now let's move our practical part and let's see how it's work. First we need to import our library. Import as pandas as pd. After that I create a two different frames. So basically I create pd.dataframe, like creating a data frame, then I take two column id and a class, and we have a 4 rows. So let me show you our first data frame here. As you can see that a very simple data frame, id and class. In class we have a b c d, and id we have integers value. In the second data frame we create id 1 2 3 4, and we create another column which is section. So this is my second data frame. Now the task is that to understand how merging function is work, how we can combine these two data frame in a practical. So let's see. So let's say that I'm going to combine, so I can combine pd dot, let me move to a practical, but for that I need to go to Python. So pd dot merge, and I'm going to pass parameter. Let's say that I wanted to create df1, df2, and I close the bracket and I will show you. Perfect. So we basically merge our two data frame, df1 and df2, and if you see the results, we combine basically these two data frame based on the common column which is id. As you can see that id we have a both common column 1 2 3 4 1 2 3 4. You can take df1 into left and df2 into right, or you can just change the position. Let's say that I'm going to in left df2, and in right I'm going to take a df1. The result will be section will be first and the class will be the second. So I hope it's clear for you. Now we need to understand the rest of parameter. Here by default it's merge based on id. What happen if we pass a different we merge based on a different column? So we'll try to understand how it's worked. So pd dot merge data frame 1 data frame 2 based on id. So as I mentioned that by default here we merge our data frame based on id, and we also specify here like merge these two data frame based on id. What happen if we merge these two data frame based on class? So if I run, it will throw me an error key error, which is class. Why it's giving me error instead of merging these two data frame? Because if we see our data frame df1 and df2, we don't have any common column. If we see the class, we have only class in data frame 1, but we don't have in df2. That's why we are get here key error. If we see the definitions that I show you, a visual representation, the definition telling us that it's combined based on the common column. So if we don't have common column, it will not merge the data frame and it will give the error that you see here, key error. So yeah, that's how on is work. Now we'll explore more about merging and what happen if we have a common column ID but we have a different items in ID. How it will work, let's see. So we have a data frame 1, we have ID and class, similar data frame, we have 1 2 3 4, and we create in the data frame similar like ID and sections, and we have 1 2 3 5. Here we have 1 2 3 4, and here we have 1 2 3 5. So 4 and 5 are different in each IDs respective to data frame 1 and data frames 2. So now let's see how we can combine. So for example, we combine pd dot merge data frame 1 comma data frame 2 based on ID, and if we see the results, we see a common between data frame 1 and data frame 2, which is ID 1 2 and 3. We're not getting results for 4 and 5. So by default it's basically merge based on a common item. Now we'll move on our next topic, which is how is a parameter that will pass inside merge, and there is a different method of how. First one is inner, take common only. The second one is basically outer, take all either is common or not. The third one is right, it take only a right column. The last one is left, it take only left column. So we'll discuss one by one, and let's say that we first take the example of inner, and I'm going to show you the, let me go to Python, and if I show you my data frame 1, this is my data frame 2, just to recall what was our data frame 1 and data frame 2. So first we will use inner method. So we will combine pd dot merge, and we have to specify df1 df2 on is equal to ID and how, the parameter that will pass how is equal to inner. So if I run, it will combine my these two data frame based on ID. The method that I use is inner. So if I see the definition, take common only. So whatever we have a common in these two data frame, which is of course we take ID, and common item is 1 2 3 1 2 3. So that's why it's show me the results based on a common only. Now we'll move to another example, which is outer, and let me change to markdown to make heading. So outer is the same way. They'll pass inside inner here, we just pass outer. Let me change to Python as well here because we need to run this code. So outer, and if I show you the results, so the outer is basically take all, outer is common or not. So we have all items here in the ID, because in data frame 1 we have 1 2 3 4, and data frame 2 we have 1 2 3 and 5. So it's basically take all and it's combined. Now we see the data frame 1 we have 1 2 3 4, that's why we get A B C D, but we don't have fifth ID in data frame 1, that's why it's showing me none. Same in data frame 2, we don't have fourth ID, but we have fifth ID, that's why in fourth ID it's showing me a none. So that's how our outer is work. Now we'll move to a next, which is a left. Let's see how the left is work. So take this example. So instead of outer, I will pass left, and let me change to Python. So the left is basically based on the left ID of data frame 1. So in df1 we have 1 2 3 4 and class A B C D. So this was our data frame 1. So it's basically combined based on the left data frame. But as we know that in right we don't have fifth ID or like fourth ID, that's why it's showing me unknown. So if I show you a right method, and let me change it to my markdown to make a heading first. So if I show you my right here instead of left, it will combine the data frame based on the left. So as you can see that, so it's merge our data frame based on the ID of our left data frame, which is df2. So we in df2 we already know that, if I show you quickly, 1 2 3 5. So we have 1 2 3 5, and it's showing me x1 x2 x3 x4, but in data frame 1 we don't have fifth ID, that's why it's showing me unhand. I hope it's clear for you. Now just a quick revisions. How is another parameter that we pass inside merge, and there is a different method inner. Basically we combine based on the common only, and we see the example here. We have a common only 1 2 3, that's why it's print my results. Outer is basically taking all, either is common or not, so it's taking all, like for example 1 2 3 4 1 2 3 4 and 5. So that's why it's take 1 2 3 4 5. Left is basically combined based on the left data frame, and right is basically combined based on the right data frame. Now we are moved to our next topic, which is indicator. Indicator, it tell how file are merged according to how operation. So it basically create a extra column, and in extra column it show us the way that how operation is work. So let me show you with the same example in the right that we see here. So let me change to Python, and if I pass my indicator and I tell us that's true, and if I run, it will create a extra column, which is underscore merge, and it tells us that how the data frame are merged. So in id1 it showed that both, in id2 both, id3 both, but in id5 based on right only. So if I show you based on outer example, let's say that, and if I run, so first three is a common, that's why it show me a merge based on both, but in fourth it create a value left only. So basically it's indicating that in our fourth id we have left, and in the fifth we have right only. So it's just an indicator, and it's telling us how data set or data file are merged based on the how, like inner, outer, left or right only. So now we'll explore further about merge, and let's see if we have a case. And the case is we have a two data frame 1 and data frame 2. We have a common id, but inside id we don't have a common element. So how we can combine these two data frame? So pd dot merge df1 df2 based on id, as you can see that it show nothing because we don't have a common item. To tackle this issue or to combine this data frame, we have such case. We use left index and right index, and we return true. So this is basically another parameter. What will happen? So it will make a different id by default with the name of idx and idy. So let's see how we can use this one. So pd dot merge df1 df2, we don't need to pass third parameter on is equal to id. Instead of that we just pass left index is equal to true, left index is equal to true, right index is equal to 2, and here you get the results. So we basically combine these two data frame by creating different IDs. So we have idx. Based on idx we combine the data frame 1, and based on data frame 2 we create idy, and we create these two data frames. So by default it's x and y. You can change the name by using suffix. So suffix is basically you basically pass another parameter and you giving the name of respective id. For example, you wanted to change id x with id1 and id underscore y with id2. So how you can do that? Simply you pass another parameter here, and let me change to Python first, and you passing another parameter here which is basically suffix, and instead of I'm going to take right left, I just take 1 and 2, and if I run, you have to pass the value in string actually to make sure. So here you can see the results. Either you just take maybe underscore so here as well. So we basically change the name of id, id1, id2, and we combine these two data frame based on a different item inside the ID. So just a quick recap: if we don't have a common item in the common columns, so to merge this kind of problem, or you merge this kind of data frame, you basically pass left index is equal to true and right index is equal to true. It will create extra ID and it will combine these two data frame. You can change the name by using suffix, and you can pass the value. You can pass any string value there and it will return.
Today we're going to be looking at concatenation. In this episode we're going to cover the concat function, ignore index, the axis, join inner and outer, keys, and sort. So what does concatenation do? Well, it takes two or more pandas objects and it stacks them together into one pandas object. And here we have a diagram where you can see we have this blue object and this yellow object. You can think of these like data sets. And if we use the concat function, we can stack them either horizontally, like this, with axis being 1, or vertically, like this, with axis being 0. In this case, we assume that the blue object on the top here is the first object being passed into the function. In that case, it will be on the left when the axis is 1, and it will be on the top when the axis is 0. So this is a cool visualization for you to be able to understand concatenation a little better. And let's start as always by importing pandas and our data sets. There we go. And the concat function works with both series and data frames. So let's create two series here. Call it S1 and S2. Make sure you use the capital S in the series. And the brackets to define the elements. And then we're going to pandas.concat. Use a bracket to define which series we're going to use. And try using S1 and S2. And there we go. So as you can see, in series 1 we have elements 1 through 4, and with series 2 we have elements 5 through 8. When we concat these in the order series 1, series 2, we have series 1 stacked on top here, and then series 2 here on the bottom. Or series 1 on the top and series 2 on the bottom. And this is actually the default for the concat function. As you can see in this diagram, the default axis is 0. So we have the first series, series 1 on the top, series 2 on the bottom. And now we're going to try the same with data frames. So let's really quickly take a look at our data frames up here. We have the numbers 1 through 5, and then their Roman numerals for data frame 1. And we have the same with data frame 2, except that it's with the numbers 6 to 10. Okay, so if we go here, we can do pandas.concat. And it's the same as with the series. We use a sequence of square brackets. And then we put in our df1 and df2. And let's see what that looks like. As you can see, the same as before, it places the first data frame on the top here, and the second data frame on the bottom. Now, throughout both of these examples, you'll notice that on the left side, the indices are going 0 through 3, and then once again 0 through 3 for the series, and 0 through 4 twice for the data frames. And this is because it actually uses the original indices of these elements here. Now, let's see what happens if we change the positions of these. We should expect that these indices will be actually the same. The only difference is that one of the data frames, or one of the series, in this case we'll use the second one first, should be at the top and the first one will be at the bottom. And then we'll take a look at how we can actually ignore the indices of these and use an entirely new index. So let's first change the positions. So the difference in this case is that I'm putting df2 first and then df1. So the second data frame and then the first data frame. And as you can see, we start from 6 to 10 and then we go from 0 to 5. So it's the same thing but in the reverse order. And once again, the indices go from 0 to 4. We'll add another code block here. We'll use pandas.concat, square brackets, series 2, and then series 1. So in the reverse order. And it's the same story here. So 5 through 8, 1 through 4. The indices stay the same. So now, let's take a look at how we can actually ignore the index. So now, let's create a code block. We'll use pandas.concat. Within we'll put our square brackets. We'll use series 1 and series 2. And then we're going to use a comma, and we're going to put the argument ignore index equals true. And let's run this and see what happens. So as you can see, we've got the same thing here, numbers 1 through 8 for both of these, except that now the index of the original series is ignored, and we have a new index with numbers through from 0 to 7. So n-1, from 0 to n-1. And we'll do the same with our data frames. And this should give us an even clearer example. So ignore index equals true. And as you can see here, we have our numbers and then their Roman numeral counterparts. So our numbers in decimal with the Arabic system, Roman numerals. And then on the left, we have indices going from 0 to n-1. In this case, we have 10 numbers, so that would be 9. And it actually ignores the index. So let's compare this to our previous results. As you can see here, we have indices 0 through 4, and then repeated 0 through 4. And here we have an entirely new indexing system going from 0 through to 9. So now we're going to take a look at axis. Now, as mentioned earlier, the default axis is 0, and it means that we stack our object vertically. But if we were to use an axis of 1, it would stack them horizontally. So to see what that looks like in practice, let's create a code block. We'll put in pandas.concat. Then we'll put in our square brackets, series 1 and series 2. And then we'll add the comma and the argument axis equals 1. As you can see now, it's created 2 separate columns. On the left, we have our index, which for both of these is the same. And the first column yields our series 1. The second column has our series 2. Let's try the same with our data frames. So df1, df2, comma argument being axis equals 1. Here we go. So column names have remained the same. On the left, as the indices are the same, they haven't changed, except that now we have data frame 1, which is here on the left, and data frame 2, which is here on the right. And I can select it here. Oh, there you go. So now we're taking a look at join. And essentially what this does is it determines whether we're going to use a union or an intersection when we're concatenating our data frames or our objects. And if you don't understand what that means, if you haven't done set theory, essentially, when we use an intersection, we take the common elements from both sets, and when we use a union, we take all the elements from both sets. So for an intersection, you only take those elements which are common between both sets. So in this case, for example, we should expect that we have a column B and another column B here. So these are 2 common columns between both data sets. So we should expect that those are the ones selected. And with a union, we should expect that all of them are selected. So to test this out, let's first run this code here to generate our data frames. And now we're going to pandas.concat with df1 and df2, and these have the same names as our prior data frames. And then we're going to add a comma, and the argument join equals, and then we're going to use our single quotation marks, and then we're going to put inner. Let's see what that looks like. So, as you can see, we have the B column here, and as we expected, this is an intersection of our two data frames, as we have columns B in both data frames, so those are the common elements. Now let's try the same thing, but with outer join. So we'll use pandas.concat, we'll put in our df1 and df2, df, and then comma, and put in the argument join equals outer. And now, as you can see, we have the column for A, B, and C, and wherever there are no elements, it just puts in nothing, or not a number. And since for B we have 4 elements in the B column, which is the common element, all of these are filled in. And one thing to keep in mind with the join parameter or argument is that the way it works changes based on the axis. So here the common elements are in the columns, but if you were to change the axis, it would be in the rows. So just keep that in mind. So let's take a look at keys. This allows us to label the individual objects. So let's say we have the data frame 1, data frame 2, right? So let's take a look at those. We'll say pandas.concat. We'll take square bracket df1, df2, and then we'll say keys equals, then we'll say data frame 1, data frame 2. And as you can see now, the areas which we have data frame 1, data frame 2 have been labeled. Now, let's copy this over for the next example, which is names, because this allows us to name these new columns which have been created here. So we're going to copy this over, and then we're going to say names is equal to, we're going to use the square brackets. We're going to put in data frame, and then we can also name this column here index. There we go, and let's see what that looks like. So now these columns have names. So which data frame it is, data frame 1, data frame 2, and then the index as well. And finally, let's take a look at sort. And what this does is when it concatenates these, it takes a look at the columns and or the rows, depending on the axis, and it decides whether to keep the order during concatenation. So in this case, it would be A, C, and B, or to sort them lexicographically, which basically just think of it as sorting the columns or the rows, okay? So, for example, if we were to sort these, we would expect that it would go in the order A, B, C, right? So let's test out both scenarios here. We'll use pandas.concat, put in our square brackets, df1, and we've got a new df1 and df2 now. So now let's take a look at what that looks like. There we go. So we've got ACB. And now if we just copy that code, and we put in the new argument, we want sort equals true, we should get this in the order ABC. There we go. So if you want to sort your columns and your rows, then yeah, there. That's how you do it.
Hello and welcome to aorbtech. Today we're going to discuss continuous series of pandas, and in this episode we will discuss about join operation. So the agenda of today's session: first we will see the basic definition of join operation. After that we will do a practical demonstrations. Then we will see a couple of methods and function such as left join, right join, outer join, and inner join. And in the last, when we have both data frame have similar columns, how we can tackle this issue. So for that we will use suffix, and then we will see a various type of suffix such as left suffix and right suffix. Now let's move forward with our first topic, which is join. Join means combining two tables or two data frame by matching their rows. So for example, here if we see the diagram, we have data frame 1. In this data frame 1 we have a two column A and B consist of 10 rows, and then we have data frame 2 with column C and D with consist of 10 rows. After that we basically apply the join function and we get 10 rows with join A, B, C, D. So we have one data frame consists of 4 column A, B, C, D, and we get 10 rows. And this is how we can join our data frame. So let's start with the practical. First we need to import our library, import pandas as PD, as we already know that used for data analysis and manipulation. And then we create a two data frame 1 and data frame 2. Data frame 1 we have A and B. Let me show you. So this is our data frame 1. We have two column, we have 10 index or rows. So then we create data frame 2. We also have 10 rows and the column is C and D. Now we already get two data frame. The next task is to basically join these two data frame. How we can join? Simply write df1 dot join df2. If I run the code, we get the results, and we basically get one data frame. How we get one data frame? Simply join df1 with df2, and this join is happen based on the matching index, because in data frame 1 we have a 10 rows and data frame 2 we also have a 10 rows. So we can do other way around. For example, instead of df1 join df2, we can do also df2 dot join df1. If I run this cell, you get the results. Instead of ABCD we get CDAB, because we join df2 with df1. That's why we get this position of these columns, but the rows results is the same. What happen if we don't have matching index or rows? For example, in df1 we have 3 rows and df2 we have 5 rows. How we can join these two data frame? Because we don't have a matching index here. So for that we'll discuss how, and how we'll see a various join method. So for example, we have a df1, and in this df1 we have a two column consist of 3 rows. So we have df2 where we have two columns where we have 5 index. So how we can join these two data frames? So let me show you with the first example, left join. Left join is basically keep all rows from left table and matching row from the right, which means that it will keep all these rows and only matching row with the df2. So how we do with the practical? df1 dot join df2 and comma where we will use how, and how will specify left, and if I run, as you can see that the results is based on the matching records, because in left table, I mean in the df1 we have 3 records, and that's why the join is happen based on the left data frame, which is df1. By default it's join based on the left. I can quickly show you. If we don't specify here, and if I just use bracket, and we get the same result. So by default when we join our data frame, it's happen based on the left join operations. So the next one is a right join. Right join is basically other way around, so keep all rows from the right table and match row from the left. So for example, if we take this line of code, instead of right left we just say that right, and if I run we get the results. So in df1 we have 3 rows, and df2 we have 5 rows, but we are applying a right join. That's why we keep all the records from the right table, which as you can see here. But as we know that in df1 we have only 3 records, that's why the rest of values show as a none, which means missing values, because we are applying right join, and that's why right join we have 5 rows, and the join is happen based on the 5 rows, and in the other case we don't have 5 values in df1. That's why the rest of 3 and 4 rows index rows we are showing names. The next one is inner join. Inner join is basically based on the matching records. So for example, in that case we have 3 records in the df1 and the 5 records in the df2, but as we know that matching is in both 3 rows. So let's see dot join and df2 how is equal to inner, and if I run we get 3 index results, because we apply the inner, and inner is make sure that only matching index are joined. That's why we get 3 rows here. The last one is basically a outer indexed. Outer index is basically opposite of inner. So let me convert to Python. It keep all the rows from both tables or data frames match where possible, and filling missing value where not. So for example, it will match all of them, doesn't matter the row are existing or not. So the maximum index we have 4 or 5 rows in that case, because we have 5 rows, so the match outer match will happen based on the 5 rows, because it will join all the rows, and in the inner based on the matching, which means based on the matching based on the minimum which is combined here. So let's apply the outer join here, outer join. So we can say df1 dot join df2, and then we apply how is equal to outer, and it will join based on the outer method. And as you can see that we have a 5 index, so that's why it's matched based on the all the possible records that was in this data frame. Now what happen if we both data frame df1 and data frame df2 have a similar name? So how we can tackle this issue? For that we will use suffix. If we go to the definition, suffix is a small word added to the end of the column name to avoid name clashes. So let's say we have df1 we have 2 columns A and B, and we have 5 rows. Then we have df2. In df2 we also have a same column name A and B, and we have 5 rows. So how we can join these two data frame although we have a similar column name? So for that we use a suffix. So left join df dot join. So we pass a parameter left suffix, we give the name underscore left, and right suffix we give the name of underscore right. So in df1 this column we change the name A underscore left, B underscore left, and then we use the second table which is df2, and we change the name A underscore right, B underscore B. Why we're doing these things? Because we have a same name, so to avoid name clashes we are using left suffix and right suffix. So if I run our code, as you see that we just change our name to remove the confusion between those similar names. That was the end of this episode. I hope it's clear for you.
Hello everybody, and welcome to the 14th episode in the aorbtech Pandas series. Today we're going to be looking at the pivot table function, and we're going to be going through index, values, agfunc, within which there is sum, mean, min, and max, and then finally we're going to be taking a look at margins. So what is a pivot table? A pivot table is a very useful tool. It allows us to restructure our data set around a specific column or around a specific variable, and it allows us to analyze our data set based on its aggregate values. What does that mean? Well, let's look at this demonstration here. Let's imagine that each of these columns represents a subject, at least from the yellow to the blue, and the red column here represents the retakes or the number of takes of a test that a student has done. So over here it would be a student, for example Alice, and we have Alice here. Alice has taken the test twice for each of these. Ben has also taken 2 tests for each of these subjects, and Chris has only taken them once. So let's say we want to take a look at the average for each of these students here on the left. What we can do is we can use a pivot table, and what it's going to give us here is it's going to give us a summary of each of the students for each subject and the average value that they have gotten. And it doesn't have to be just an average. We can actually change the aggregate function as it's so called, to be anything from the sum of the values to the minimum value or the maximum value. But the mean or the average is just the default aggregate function that we use. So we're going to start, as always, by importing pandas and our data sets. And let's really quickly take a look at these data sets. That's the games data set. So we have a number of games here that are stored with the name of the player, the score that they gathered, and as well as the coins that they gathered and the rounds that they survived. And some players here repeat. So we have Ace, which repeats a couple of times, Blitz and Comet also repeat, and I believe Echo and Flash are unique players. So now let's look at revenue. As you can see here, this is stored based on a number of regions, the products that are being sold, the revenue gained from those products, and the number of units sold of each of those products. So now let's take a look at pivot table or index. So to create a pivot table, first we're going to take, let's say, our games data set. We're going to apply the pivot table function. Within that, we're going to put index, and this is going to tell us which column we're going to restructure our data set about. So let's say for each of these names or each of these players, I want to get their average scores and coins gathered and rounds survived. So we're going to set the index column to name. And now let's see what it gives us. There we go. So we have each player, so Ace, Blitz, and Comet, which repeat a couple of times. So they have some values which are non-integer values here. So we have like 303.33 recurring and 291.25. And as you can see, for players who only had one entry, the values are much more normal. We have values like 256, 265, sorry, for each of these, and then of course these values here. And we can also try and do the same with our revenue data set. Set the index to the region, and this is going to spit an error at us, and then I'm going to explain why. Here we go, and let's read what it says. Aggregate function failed. What does that mean? Well, the mean function is the default aggregate function. So if we take a look at our data set, we can try and figure out why. So we've set the index column as the region here. So every other column here, it's going to try and take the average of these using the aggregate function, and that gives us the biggest clue as to what's happening here. Because if we look at the first column, which is labeled product, we have strings here and not numerical values, and you actually cannot apply an average to string values, as you might know. So how can we fix this issue? Well, we can actually exclude the product column by using the values parameter. So let's try and use this code again, only this time we're going to select the values, and since we're selecting multiple, we're going to use the brackets here, and we're going to put in that we want the revenue and units sold columns. So revenue and units underscore sold. And now it should give us a proper pivot table. And there we go. So now in terms of the region, we have the revenue and units sold and their averages. And we can also do the same with our games data set. So games.pivottable. Then we're going to take the index as the name column, and we're going to set the values to, let's say we want to look at just the score. So we'll put in score. There we go. As you can see, we have a pivot table, except that we've excluded all the other columns, and we're focusing just on the score of each player, or the average score of each player. Now, let's say we want to change the aggregate function. We don't want to use the mean. So first of all, let's put in some code here. let's try using sum here. We'll take our code from before here, revenue. We'll take a look at revenue first, and we want to take a look at the sum of all the values. So sum of all the revenue and units sold. So we'll use the argument ag func equals, and then we're going to set it to sum. Okay, and let's see what it gives us. There we go. So now, instead of giving us the mean, it's giving us the sum for each of these columns here. And we can do the same with our games data set here. So if we put in ag func, so aggregate function, and then we'll set it to sum. And there we go. And we can copy these over, the code from them. We can put them here. So mean is the default, but we can also try setting it here. There we go. And we can actually compare these values, or at least the first two, to the values that we get from the original code that we did. So if we look, we have 1908.3 recurring, and if we go up here, we have 19083 recurring. So we can see mean is indeed the default aggregate function for these. So now we can also try changing it to min. And what this is going to give us is the minimal value for each of these entries. So for each column, it's going to take a look at all of the numbers, and it's going to tell us of those numbers for each player, which was the smallest. So this is the smallest score that each player has managed to attain. And we can do the same with our revenue data set here. So we set the ag function to min, the aggregate function, and now it's going to give us the minimum revenue and the minimum units sold for each of the regions. And finally, if we want to see which is the maximum or the maximal value for each column, we can use the max aggregate function. As you can see here, this is the highest score that each player has managed to attain through all of their games. And finally, we can do the same thing with revenue. Set it to max, and there we go. This is the maximum revenue, maximum units sold. Finally, let's take a look at margins. What does margins do? Well, it gives us a row at the end of our data set, which gives us the aggregate function applied to all of the values in the entire column. So we can actually copy this code here, and we can add in the argument here. Margins equals true. So we want margins. And as you can see here, we have east, north, south, and west, and finally all. So we have the aggregate function max applied to all, and we can also change this to mean. So this is the mean for all the revenues from each of the regions. We can set this to minimum as well and see what we get. We can also set this to sum. There we go. So this is the total sum of revenue from all the regions. And we can also do the same with the points here from the games. So, or the score. So we can put this here. We can add the argument margins equals true. And let's change the aggregate function to mean for this one. So at the bottom here, we have the mean or the average for all of the players and their scores. And we can also remove this values here, so we can take a look at all of the different columns. So as you can see here, and then we can use this row here to compare against each of the players. So for example, Ace here is actually above average. Or their coins gathered and rounds survived and score all indicate that they are an above average player, because all of these average scores for each of the players here are actually below all of their scores. So you can see why this is actually a very useful way to analyze our data sets, because it gives us some context on each of these columns with respect to a specific column. Hello everybody, and welcome to the final episode in the aorbtech Pandas series. Today we're going to be taking a look at the melt function. We're going to be going through ID vars, value vars, var name, and value name. So what does the melt function do? in the simplest terms possible, what it does is it takes a wide format data set such as this, where we have lots and lots of columns, and it converts it into a long format data set. So it converts it to something more like this, and you would expand this out. So we have just a few columns and then a lot of rows, which can sometimes make it easier to look at our data and understand our data. And let's start as always by importing pandas and our data sets, and let's take a look at our data sets. So we have one named visits, which looks like this. As you can see, there's a bunch of different columns here. This is for our website, so we have the home page, the about page, contact, products, and blog. And we have a number of dates here, ranging from the 21st of February to the 25th. And we have the number of visits on each of those days for each of these different parts of the website, or yeah, each of these websites. And then we also have scores, and this is what it looks like. So we have a number of subjects here as the columns: math, science, history, English, and music. And we have a number of students and their scores. So we have Alice, Brian, and Clara. So let's see what happens when we melt these data sets. Now we're going to get something very long. So we're going to take visit.melt. And as I said, it's going to be very, very long. So if I print this out, it should take up a whole bunch of space. There we go. Look at all those entries. And so what it's done is it's split our data into variable value pairs. And what does that mean? Well, as we can see here, we have the variables on the left and their corresponding values on the right. So if we go through these columns, just to try to make sense of this, we can see we have a variable date, or a column date. When I'm referring to a variable, in this case, I'm talking about the columns. So we have date, and for each of the rows in that column, we have, well, a date. And so it looks at all of those entries, and as you can see, we have from 21 to 25, just as we do in the dates column. Let's look at the home variable, or the home column. We have 120, 95, 110, 130, and 100. And we also have that here. So as you can see, we have the variable on the left and then the value on the right. So essentially, it's looking at each one of these entries. It's telling us which variable is connected to it and which value is connected to it. And we can also do the same with our scores dataset. So scores.melt. Once again, we're going to get something very long. So here we have all the relationships between the variables and their respective values. So for each student, this is explaining basically all of our students that we have. So we have a student called Alice, a student called Brian, and a student called Clara. And we have a maths score called 78, 85, and 92. And you'll notice that we lose the connection between each of these. It's not entirely possible to discern whose maths score this is, 78. But if we go up to our original data set here, we can see that 78 actually belongs to Alice. So it does go in the same order in this case, but in most cases it would be quite difficult to tell. And you can also use a different notation for this. We're just going to cover this quickly. Pandas.melt, and then you can put in the data set here. So let's just do it with scores. So there's a different notation there. We can write that down. There we go. So if we go back to the diagram, you'll notice that we have to choose a column here, which we will use as the reference point. And this is called the ID variable, the ID var. And so we're going to try this out on scores. So we'll use scores.melt, and then we'll put in ID vars equals, and then we'll put in, let's say, student. And let's see what that does to our data set. So now we have an additional column. And this is the ID column, the ID variable. And what it's doing essentially is it's saying, in terms of each student, right, what are the variable value connections, or the variable value pairs that we can draw from each student. So Remember how I said earlier that it was difficult to tell the context between which of these scores belongs to who? Well, now we can say that for Alice, there is a math score of 78. Alice also has a science score of 82 and a history score of 75, for example. So this makes it much easier for us to be able to draw conclusions based on each of these students. We have just a direct connection between each of these variables and their values. So for example, we can say Clara has a maths score of 92, right? So it's very direct. It's student has a score of so and so. And we can do the same with our other data set. Visit, so to the website. So visits.melt. And we'll say ID var equals, and let's say we want to take a look at this in terms of, let's see here, in terms of the date. There we go. So for each date, we have a part of the site or a page and the number of visits that that page got. So on the 21st, the homepage got 120 visits. On the 22nd, the homepage got 95 visits. On the 23rd, the contact page got 15 visits. And there we go. So we can draw direct conclusions from this. Now, looking at each of these, we can tell clearly that the variable here is just the subject, right? So for each of these, we have maths, we have science, history, English, and music. So these are all the subjects, right? And these values here, these are the scores. So what if we want to rename these columns here so that's more easily represented? Well, we can use var name and value name. So I'll just put in scores here, .melt, and I'll add a var name equals, and I'll set the variable name to subject. Now if we take a look at that, we see that this column here has the variable column name that it used to be replaced with subject. And I can actually copy this code, bring it over here, and I can also change the value name. So I can set value name to score, because there's a score for each subject. And now these make a lot more sense. So we have student column over here, the subject, and the score that they received. And just to practice, let's also do this with the visits data set. So we'll go into var name, and let's take a look here. So each of these is a different page in the site, right? So we have the dates, and we have different pages, and the number of visits, okay? So we're going to change the variable name to page. Let's see what that looks like. So now this column has been renamed, but we still need to rename the value column. So we'll copy this code, we'll bring it down here, and we'll add the argument value name or val name. Oh, sorry, value name. And we'll change it to visits. There we go. Or you can also change it to hits if you prefer that terminology. So we have a date, we have the page, and we have the number of visits. So it makes it much easier now. We can look at these and we know exactly what each of these columns means. And with the end of this episode comes the end of our Pandas course. We hope that you enjoyed, and if you liked this video, then make sure that you like it on YouTube and subscribe to our channel. And if you want to see more of our videos when they come out, you can hit that bell icon to notify you when they do. Please share with a friend to spread news of our channel. If you would like to see the source code, as always, it's available in the description, or our website, which is also available in the description. If you would like to check out our other series, make sure to do so at our channel. We have a Python series, a NumPy series, and a few upcoming series. And if you have any questions, leave them in the comment section below and we'll be more than happy to answer them. For now, that's all. Have a lovely day and goodbye. Hello everybody and welcome to the final episode in the aorbtech Pandas series. Today we're going to be taking a look at the melt function. We're going to be going through ID vars, value vars, var name, and value name. So what does the melt function do? in the simplest terms possible, what it does is it takes a wide format data set such as this, where we have lots and lots of columns, and it converts it into a long format data set. So it converts it to something more like this, and you would expand this out. So we have just a few columns and then a lot of rows, which can sometimes make it easier to look at our data and understand our data. And let's start as always by importing pandas and our data sets, and let's take a look at our data sets. So we have one named visits, which looks like this. As you can see, there's a bunch of different columns here. This is for our website, so we have the home page, the about page, contact, products, and blog. And we have a number of dates here, ranging from the 21st of February to the 25th. And we have the number of visits on each of those days for each of these different parts of the website, or each of these websites. And then we also have scores, and this is what it looks like. So we have a number of subjects here as the columns: math, science, history, English, and music. And we have a number of students and their scores. So we have Alice, Brian, and Clara. So let's see what happens when we melt these data sets. Now we're going to get something very long. So we're going to take visit.melt. And as I said, it's going to be very, very long. So if I print this out, it should take up a whole bunch of space. There we go. Look at all those entries. And so what it's done is it's split our data into variable value pairs. And what does that mean? Well, as we can see here, we have the variables on the left and their corresponding values on the right. So if we go through these columns, just to try to make sense of this, we can see we have a variable date, or a column date. When I'm referring to a variable, in this case, I'm talking about the columns. So we have date, and for each of the rows in that column, we have, well, a date. And so it looks at all of those entries, and as you can see, we have from 21 to 25, just as we do in the dates column. Let's look at the home variable, or the home column. We have 120, 95, 110, 130, and 100. And we also have that here. So as you can see, we have the variable on the left and then the value on the right. So essentially, it's looking at each one of these entries. It's telling us which variable is connected to it and which value is connected to it. And we can also do the same with our scores dataset. So scores.melt. Once again, we're going to get something very long. So here we have all the relationships between the variables and their respective values. So for each student, this is explaining basically all of our students that we have. So we have a student called Alice, a student called Brian, and a student called Clara. And we have a maths score called 78, 85, and 92. And you'll notice that we lose the connection between each of these. It's not entirely possible to discern whose maths score this is, 78. But if we go up to our original data set here, we can see that 78 actually belongs to Alice. So it does go in the same order in this case, but in most cases it would be quite difficult to tell. And you can also use a different notation for this. We're just going to cover this quickly. Pandas.melt. And then you can put in the data set here. So let's just do it with scores. So there's a different notation there. We can write that down. There we go. So if we go back to the diagram, you'll notice that we have to choose a column here, which we will use as the reference point. And this is called the ID variable, the ID var. And so we're going to try this out on scores. So we'll use scores.melt, and then we'll put in ID vars equals, and then we'll put in, let's say, student. And let's see what that does to our data set. So now we have an additional column. And this is the ID column, the ID variable. And what it's doing essentially is it's saying, in terms of each student, right, what are the variable value connections, or the variable value pairs that we can draw from each student. So Remember how I said earlier that it was difficult to tell the context between which of these scores belongs to who? Well, now we can say that for Alice, there is a math score of 78. Alice also has a science score of 82 and a history score of 75, for example. So this makes it much easier for us to be able to draw conclusions based on each of these students. We have just a direct connection between each of these variables and their values. So for example, we can say Clara has a maths score of 92, right? So it's very direct. It's student has a score of so-and-so. And we can do the same with our other data set. Visit, so to the website, so visits.melt, and we'll say id var equals, and let's say we want to take a look at this in terms of, let's see here, in terms of the date. There we go. So for each date, we have a part of the site or a page and the number of visits that that page got. So on the 21st, the homepage got 120 visits. On the 22nd, the homepage got 95 visits. On the 23rd, the contact page got 15 visits. And there we go. So we can draw direct conclusions from this. Now, looking at each of these, we can tell clearly that the variable here is just the subject, right? So for each of these, we have maths, we have science, history, English, and music. So these are all the subjects, right? And these values here, these are the scores. So what if we want to rename these columns here so that's more easily represented? Well, we can use var name and value name. So I'll just put in scores here, .melt, and I'll add a var name equals, and I'll set the variable name to subject. Now if we take a look at that, we see that this column here has the variable column name that it used to be replaced with subject. And I can actually copy this code, bring it over here, and I can also change the value name. So I can set value name to score, because there's a score for each subject. And now these make a lot more sense. So we have student column over here, the subject, and the score that they received. And just to practice, let's also do this with the visits data set. So we'll go into var name, and let's take a look here. So each of these is a different page in the site, right? So we have the dates, and we have different pages, and the number of visits, okay? So we're going to change the variable name to page. Let's see what that looks like. So now this column has been renamed, but we still need to rename the value column. So we'll copy this code, we'll bring it down here, and we'll add the argument value name or val name. Oh, sorry, value name. And we'll change it to visits. There we go. Or you can also change it to hits if you prefer that terminology. So we have a date, we have the page, and we have the number of visits. So it makes it much easier now. We can look at these and we know exactly what each of these columns means. And with the end of this episode comes the end of our Pandas course. We hope that you enjoyed, and if you liked this video, then make sure that you like it on YouTube and subscribe to our channel. And if you want to see more of our videos when they come out, you can hit that bell icon to notify you when they do. Please share with a friend to spread news of our channel. If you would like to see the source code, as always, it's available in the description, or our website, which is also available in the description. If you would like to check out our other series, make sure to do so at our channel. We have a Python series, a NumPy series, and a few upcoming series. And if you have any questions, leave them in the comment section below and we'll be more than happy to answer them. For now, that's all. Have a lovely day and goodbye.